SQL language doesn't offer. So these are some gaps that are observed for time series data and traditional RDBMS. So here comes the timescale DB. So yes, this is possible. You can store your time series data in RDBMS using timescale DB. So timescale DB is an extension for your Postgres database. So all you need to do is just install the timescale DB extension to your existing Prometheus database, or you can just run the timescale DB itself. So timescale DB can scale up to hundreds of billions of metrics using a single timescale DB node. So yes, trust me. So all you need is to run a timescale DB single node, and it can scale up to hundreds of billions of metrics. So that's the scale what we are talking about with timescale DB. And also timescale DB offers the columnar time series compression that is using Gorilla. So you might have heard about the Gorilla compression from Facebook. So timescale DB leverages Gorilla compression and delta over delta algorithms to achieve efficient compression for your time series data. And time series data can also be stored in horizontally scalable multi-node version. So timescale DB can be run as a single node, also as a multi-node version. So you can just scale your timescale DB into multiple nodes as your needs and scale grows. So let's talk about one major question I just keep answering when I advocate RDBMS and Prometheus data is that time series data has high velocity and it continues to grow over a period. How do we handle it in tables? Because we know tables are like as the new data just flows in, the table size just keeps growing. So if you are trying to insert like millions of data points into a table, the size of the table just grows. And if you want to do any querying, inserting, it just becomes the bottleneck because the size is too high now to do any kind of operations in the table. So timescale DB has its own tables called hyper tables. So I would say this as your relational database tables on steroids, because the power of hyper tables is so much. It's like it's an abstraction layer and a primary point of interaction for your data, the hyper tables in general. And it also offers like the hyper tables as simple as your normal traditional table. So you can create the tables, you can do indexing, you can do inserting and selecting the data. All kind of operations on hyper tables is possible. And hyper tables internally, what they do is they automatically split the data into chunks. So if you are having millions of data points in hyper table, so these are divided into small chunks based on time interval and region of the partition key space. So at any point in time, if you're doing querying or inserting, you're just handling with one chunk under the hyper table, and which makes the querying and insertion much efficient. So we just handle the table sizes with hyper tables. So you don't need to worry of how does this work in the traditional tables of RDBMS, because hyper tables does that for you. So these are some community shoutouts for timescale DB. So I just felt like showing to you to show what timescale DB offers to the community. So currently timescale DB is being used in crypto trading and doing observability. So it's being used in wide variety of fields. So I'm personally very happy to see this kind of acceptance and so much of growth for timescale DB. So yeah. Let's talk about why you store Prometheus data in RDBMS, because you are by now you are convinced that the RDBMS and Prometheus just are compatible with each other, and it makes sense. But why exactly? Why you should store your Prometheus data in RDBMS? Because Prometheus out of the box already offers you PromQL for querying. If you manage to store your Prometheus data in RDBMS, you can do querying using SQL as well. You can unleash the power of SQL on your Prometheus data. You can now you are able to perform aggregates, OLAP cubes over a long period of time. So just imagine if you are storing Prometheus data for last 6 months, 1 year, how much leverage you can get using SQL, because as the data grows, you can do so much of complex operations on your data. You can do joins with other data such as logging, tracing data, and it's with your business data, and you can correlate with different data points, and you can do some analytics and do predictive analysis to how does the future trends look like. So everything is possible with SQL here. And you can also do any kind of machine learning and predictive analytics, because SQL and the RDBMS is already being used in these areas, and it also offers you operational maturity such as security, like table level and row level permission. So if you want to grant permissions to a particular table that is a particular metric, it's totally possible. You can handle all the security within RDBMS itself, and you can do consistent backup, restore, and high availability with RDBMS. So as RDBMS have been in the industry for a while now, so all the major features and all the features you expect from a database are already present out of the box for you. So let's talk about the Prometheus data model and how does this data model fits into the RDBMS. So we have seen the Prometheus data model in the previous slide, that we have a metric name, we have labels, timestamp, and the actual value what we are trying to capture. So if you see in this in the other picture here or towards the right, so what we are doing is we're just asking, give me all the data which exists in prom data schema under the table called Go threads. So Go threads is a metric here. So in timescale DB, we designed the schema in a way that each metric fits into a table. So each table denotes a metric, and all the data within that table is the samples for that metric. So if you see here, we have one column called time and the other column called value and the third column called series ID. So the time denotes the timestamp, value denotes what was the value captured at that time stamp, and series ID denotes the label set. So we just do a reference of series ID from other table where it references the actual label. So let's talk about how we do the schema in the upcoming slides. But this is the overall Prometheus data model and how does your data looks like in RDBMS. So like this is what I was just talking in the other slide. So we just decided to go with one table per metric compared to one global table, because we just felt like if you have one table per metric, you will have less interference between metrics, because it's easy for you to read and write. And in most of the cases, you will be querying per metric, because if you are doing any kind of visualizations in Grafana, you will use single metric queries. So it will be very much less interference between metrics, and it's easy and efficient for querying and insertions both. And you'll have more control over retention, permissions, and compression too, because if you want to do any metric level retention, it's totally possible here. And you can also give permissions per metric as well, and compression works much efficiently in per metric basis. So there's one problem here, which is like in the schema level, is that how do you group by namespace? That is, for each series, we join all label IDs from the label table and find the namespace. So it's like it just feels like it's complex, but no, we just made it a much simpler by like the goal was to avoid iterating over labels array and join that label table every time you are querying. So we didn't want to do that overhead operation. So instead, what we have done is we did constant time array index access, which is assign a unique array index to each key. So you'll have array of elements, and each index in that array of elements denotes a specific key, and the value like if you see in this view columns, labels of 0 denotes the label key as app ID, and labels of 1 denotes the zone ID. So we just did this array based indexing for all the labels, and which is much efficient than doing the actual iterating over labels tables and then joining the table. So this is how we are doing it currently. And so now your data has been designed and is residing in your timescale DB. So now you get the actual power of SQL. What you can do with SQL, which cannot be done with PromQL. So you can do fine-grained aggregation control. So you can see an example SQL query, which is possible only with SQL but not with PromQL. We'll talk more about these SQL queries in the demo. And we also have, you can also do rollups and cubes, that is group by rollup using app version ID and rollup ID, which is totally possible with SQL. And as I was talking, you have the security in the database level itself. That is, you can grant access to a particular user for a particular metric. So that particular metric and its time series data can only be accessible by Bob in this case. And we also offer joins, which is if you are having another business data or other kind of data which is residing in the same database, you can just do joins between the tables and you can correlate the data from different tables. And the statistical functions are also available out of the box for you. So you can just write your own statistical functions to analyze your time series data. And as you have seen, with SQL you have got that more power, but with more analytics you'll get more unlimited power. So in GitHub we have a repository called timescale analytics, where we are actively working on analytical functions for time series data, and that offers you more unlimited power. So you can just go beyond the SQL for time series data to analyzing the time series data. So you can just go one step ahead and do this analytics. That is like, these are a few of our analytical functions which we have developed in the recent past. So firstly, like the graphing analytical function, this is ASAP smoothing. So it's like a data smoothing algorithm. If you have last 5 years or 10 years of data points, if you want to do any kind of graphing, you don't need all the data points. Like if you're having time series data with a difference of 1 minute or 2 minutes, it's so much of noise if you want to graph over 5 years of data, and it's too many points. So you, this ASAP smoothing reduces this cyclic noises, and it just gives you the overall rough shape of your data, so that you can do the visualization with much more ease and with reduced data points. And we have something called LTTB, which is largest triangle three buckets. It's a downsampling method. So you don't need all the data points per visualization. It just picks the main downsample. It just does some downsampling on the fly, and it just visualizes the rough graphing for your data. And we also have approximates, which is an like hyperlog log to count the distinct data points, and percentile approximation with using t digestion and UDD sketch. So you can just go through the timescale analytics docs. We have the complete docs, like where we like how did we implement this and how you can leverage this function. So you get all this information in timescale analytics GitHub repository. So let's talk about what is PromScale now. So we have seen what is Prometheus, why you need to use RDBMS, and the traditional RDBMS gaps with time series data, and the timescale DB fits into it. And now you're convinced that you can store your Prometheus data in timescale DB and leverage all the native functionalities that your time series data require. So let's talk about how you can send your Prometheus data to timescale DB now. So here comes the PromScale. So the observability team at Timescale is working on PromScale. So PromScale is an open source long-term store for your Prometheus data, and it's built on top of Timescale DB. So the leading relational database for time series. So that's the definition what it says. But imagine PromScale as a bridge between your Prometheus and your Timescale DB. So usually you write all your Prometheus data to a remote storage systems using the remote write endpoint, and PromScale also just works in that way. You just write all your Prometheus data using the remote write endpoint to PromScale, and PromScale ingests it into Timescale DB. And in Timescale DB, all the magic happens. Like you get out of the box compression, you can do downsampling using continuous aggregates, you can do per metric retention. So all this are already present in Timescale DB for your time series data. And this is mainly designed for analytics. So you can run all kind of analytics using PromScale. Once your data gets into Timescale DB, you can run all kind of analytics using SQL and using analytical functions designed by Timescale. So now I need to answer why PromScale, because you have many remote storage systems out there, and why you should opt for PromScale. So PromScale offers you backfilling, that is easy support of ingesting your older data. If you have any data like older Prometheus data residing in other remote storage systems or in the Prometheus itself, you can just do backfilling to the prom scale, and it just works, and it just ingests that data to the timescale DB. And if you're planning to do any kind of backfilling between remote storage systems, or if you're trying to migrate the data between remote storage systems, please check out our other project called Prom Migrator, which is within the PromScale GitHub repository. It migrates the Prometheus data between remote storage systems. And coming to another feature why you should opt PromScale is that you have flexible querying. That is, you can use PromQL and SQL. So PromQL just acts as a Prometheus data source in your Grafana, and you can just run all your PromQL queries on top of PromScale. So in PromQL compatibility test, PromScale has scored 100 out of 100, so we are fully compatible with PromQL. And you can also do flexible ingest, that is, you can do Prometheus based remote write ingest into PromScale. Also, you can get your custom time series data and transform it to a JSON object, which we exposed. And there is a dedicated endpoint to push your custom time series data into PromScale. So it's totally possible. It's not just restricted or confined to Prometheus data. You can also get your own time series data and transform it and just push it into PromScale. And mainly, it's very easy to deploy and operate. So this is the architecture of PromScale. So you have Prometheus on the left, and Prometheus does the remote write and read to the PromScale, and PromScale just runs as a single instance. It doesn't need any stateful set or any state, so it just works as a standalone stateless application, and it is dependent on timescale DB, so it just talks to the timescale DB. So as the data flows from Prometheus, PromScale just writes it into timescale DB. If there are any queries to PromScale, PromScale queries to timescale DB and just answers the queries. So if you see on the right, the PromScale is compatible with Grafana. So in the data sources of Grafana, you can just add PromScale under as the data source type Prometheus, and it just works for all your PromQL queries. And you can also build your PromQL queries using PromLens by directly pointing it to PromScale. And all kind of SQL tooling in the community just works with timescale DB. So any tool that talks to SQL, you can just connect it to timescale DB, and it just works for you. So let's do a quick demo on how to use PromScale timescale DB with your Prometheus data. So I have a Grafana running here, so I can just show you what is my environment. So go to kubectl get pods. So you can see I have a kind cluster running. Yep, I have a kind cluster running, and it has the complete monitoring stack for Kubernetes cluster deployed. So we have another project called TOBS, which deploys the complete observability suite for Kubernetes cluster, and I just use that. You just need to run TOBS install, and it just installs all the observability stack for your Kubernetes cluster. So let's do TOBS Grafana get password, because I need to log in into my Grafana dashboard. So I need the password. So usually if you need to get the Grafana password, you need to get into the Grafana pod, see the underlying mounted secret, get into that secret, decode the base 64 encoded string, and then get the secret. So that's a bit long. So you just need to run TOBS Grafana get password. A single command just shows you the password, and you can directly use it. The user is the default user here is admin, and I'm just copy pasting the password. You are in. So you just got into the Grafana dashboard. So TOBS out of the box offers you all this Kubernetes mixins dashboards. So you can just get into Kubernetes API server and see all the graphs for your API server. And all this data is currently being powered up by timescale DB. So all this data you see here, last 1 hour or 12 hours of data, is coming from the timescale DB. So it's in timescale DB. So all this, if you see the data sources here, the data sources which we are using here are PromScale. So you need to we just added prom scale endpoint as data source type as Prometheus. So all the dashboards you're seeing are currently being queried from prom scale itself. So yeah, and you have another data source called timescale DB itself. You can run the SQL queries in Grafana directly by pointing the data source as timescale DB. So let's build a dashboard now. So I'm just creating an empty panel here, and so in prompt scale, you can just do go underscore go routine. So you can see all these metrics are currently being queried using from prompt scale. So you see the data just exists there. And let's query from timescale DB using SQL. I'll just write a sample SQL query here and let's see how does that work. So we have a getting started prompt scale docs here. So you can just follow this docs to set up the prompt scale and see how does the SQL queries work. So I'm just taking uh, SQL query to query our database. So you just need to add the prefix as the schema. So prompt data is the schema where all these tables exist. So I'm just pointing the visualization as a table to see what exactly does this offer. So you can see that this table contains timestamp and value, and this is what the data actually exists there. And you can do visualization as time series, and you can do all kind of visualization here, and it just works. So what we will do is we'll also get into timescale DB and query using SQL and see how does this metrics are stored there. I'll do tops timescale DB connect. So which connects me to the timescale DB. So now we are into timescale DB, and I'll just do list me all tables. So from data is the schema in which all the table exists. So let's do this. So you can see that all the tables are basically the metric names. So you just run enter, you can see all the metrics here. So all these metrics basically contains your Prometheus data with timestamp, value, and series ID, which denote the label value pairs. So this is the demo. So you can see you can query directly using SQL. You can query your Prometheus data using PromQL, and everything just exists here. So let's talk about what is the prompt scales vision. So the prompt scales vision is that a single flexible database for your metrics, logs, traces, and with the power of SQL. Just imagine if you have one single database for the metrics, logs, traces, and even for your business data, and you have an ability to query all this data using SQL. So you can just get all the unlimited power for querying and for analytics on all the data you have stored so far. So it just gives you all that power for your data. So why one database? Because currently different types of data is being stored in different databases, but why you should opt for one database? Because traditionally we as database company, we know that databases are hard to run because you need to be dealing with the state PVCs, etc., and you need to manage the backups, high availability, failover, security, scaling and tuning as the scale of your reads and writes increases to the database. You need to manage all this. So why deal with this multiple times with multiple databases? So just have one database. All the lifecycle management of the database is very minimal, and also you can leverage joins, correlations, analytics, and predictions of all the different kinds of data which just sits in one database. So you just get all the power if all your data is in one database. And to learn more about prompt scale tops, you can just visit this URL. So we have slides, resources from this talk on like PromCon 2021 also has more introductory details of prompt scale and what it exactly does. And we have tops the observability stack for Kubernetes. So it's the tops GitHub repository. You can go check it out and you are just one command away from installing the observability stack into your Kubernetes cluster, and it ships the timescale DB and prompt scale for you. So you can examine, evaluate how does that work for your needs. And we have prompt scale in GitHub repository, so you can go check it out there with all the docs and everything there. And you can also talk to prompt scale team in timescale DB Slack community hash prompt scale channel. So we are the complete observability team is active there, so you can shoot up all your questions there. So that's all. So thank you. Thanks for your time and listening to this session. And hopefully, I think that you'll start your journey to use RDBMS for your Prometheus data, and can't wait to see your success stories for this. Thank you.
Alrighty, so that was a really interesting talk, and I just want to share that yeah, now we'll be talking about uh, uh, the talk that we have next is running Elasticsearch on Kubernetes. So it's going to be taken by Aravind. Aravind is a passionate evangelist in technology. He loves to meeting developers and helping solving their problems. He's a backend developer and has 8 years of development experience. Currently, he works as Elastic as a developer advocate and looks after the developer relation function of India and Southeast Asia. We also have Ashwin Murali, who is a seasoned infrastructure and engineering leader with extensive cloud experience. He ran DevOps for Zoomcar, Fiber, and more recently, Verlo. So now we'll be starting with the session, and if you have any particular questions, feel free to put it in the chat, and we'll also be answering some questions.
Running Elasticsearch on Kubernetes talk. I am Arvind and I work at Elastic as a developer advocate. I hope some of you might know or have seen me at other conferences or have spoken to me or I would have interacted in the community circles. I blog at arvind.dev and you can DM me even after the conference on my Twitter handle. So in this talk, I'll specifically talk about how do you deploy the Elastic Stack, which is also called as ELK, on a Kubernetes. Kubernetes is a very popular container orchestration system, and then obviously Elasticsearch is a very popular general purpose search engine, log analytical engine. People use it for wide variety of real-time analytics projects, etc. We'll quickly take a look at the various things on running Elasticsearch on Kubernetes. Now, Elastic Stack, as you know, is has multiple components, and it's a free and open stack. Elasticsearch is the search engine. It's a NoSQL data store as well, and Logstash and Beats are data ingestion data shippers or data ingestion modules wherein you could ingest data through Logstash and Beats. And then you have Kibana, which is a visualizer that sits on top of Elasticsearch. Most people use ELK and like thinking that pull the data through Logstash and just into Elasticsearch and Kibana. But over a period of time, there are many things like Elastic Agent or other agents through which you could directly ship data to Elasticsearch using ingest pipelines and do a lot of stuff over a period of time. And there are three specific solutions that people build or people use Elasticsearch for. One is search, and another is like the observability, where collecting of logs, metrics, and traces. And the other one is like using SIEM, etc. So the stack is used by, say, be it if you are a developer developing applications on Elasticsearch for building search, etc., or if you are a practitioner building DevOps pipelines, or running your infrastructure or doing anything else, or if you are a product owner checking your whether your application has been doing well or not, or if you're a security practitioner working in the information security ecosystem. So you might be using or like Elasticsearch, or like you might be interacting with it if you are one of these users, or many people in the community use this product for different use cases. Now the key differentiator here is like it's a platform agnostic, vendor agnostic tool. That means you could run it anywhere, and obviously you could run it on Kubernetes. The talk specifically the topic of the talk today. So quite some time back, we have this Elastic Cloud on Kubernetes release, and then that is how you could take more and understand about like how do you run this entire stuff. Now I would, before diving specifically into this topic, I would also like talk about what's Kubernetes like for people who are like like pretty much starting up with Kubernetes. I know like this is a Kubernetes specific talk or specific conference. But then like I expect to bootstrap some knowledge of Kubernetes onto you all again. So basically, in a nutshell, Kubernetes contains a bunch of pods which could run multiple different type of container runtimes, and Docker is one such container runtime. And it runs on a fleet of nodes, and it can have services, it can have secrets where you could store certificates, passwords, kind of a thing. It also has a NAS volume mounted systems that you could mount, different types of storage that you could mount onto Kubernetes, and then it can manage on a large scale. It is like a distributed system again. And then there are multiple moving parts, and it helps you to orchestrate your workloads and achieve scale and through reliability. And then many other resources that exist in the Kubernetes ecosystem are like obviously deployments. You do multiple deployments of like say Nginx deployment or your application specific deployment, which has say certain number of replica sets, etc. Or if you have something called daemon sets, which is like a a pod running on all nodes, which is common across the Kubernetes, and like it probably used to collect stuff like that, data from the other pods or other containers as well. So another thing is like persistent volumes, and it's like a volume that can be attached to different pods. Then the most important thing for this talk is a stateful set, and stateful set is something that helps run a distributed system like Elasticsearch run on Kubernetes, which I told like again is a distributed system. So Kubernetes so far is really great for a stateless system, and then Elasticsearch kind of data stores contains the state and exchange information between multiple nodes, and then stateful sets help you to do a lot of these use these stateful sets use this to deploy this Elasticsearch kind of systems actually. So all the resources that you deploy are like JSON objects within a well-defined schema. You have this is what is like called as a declarative way to deploy your infrastructure, and then give it an annotation, and then Kubernetes will deploy it and create that infrastructure for you. In a large scale, like this is how the high level architecture would again look like. Like you have multiple controllers, an API server through which you interact with tools like kubectl, and then you have nodes which runs kubelets, and there is a state store like etcd which contains all the information about the resources, etc. Like yeah, as I said, these are the things that are available here. Like etcd is a persistent distributed key value system which watches all the things, stores the information. Then API server contains all the APIs to look at like what sort of resources are happening. You could watch that again. The user often with kubectl or like some other command line tools would interact with the API server. Then you have kubelets, which is like an agent running on a node and helps with like manage the corresponding containers on the host. And then obviously controllers, which is the important topic that we are going to talk about in a minute, which contains which watches again the resources through the API server, and then also like kind of processes stuff with their own logic, like and interact with external systems probably. So there are some existing controllers in Kubernetes ecosystem, which is like a default controllers. Like you have schedulers, which kind of watches the pods, assigns them to a node. If you have some certain settings declared in your YAML while you are deploying, it follows all the settings and makes sure the pods are always available, etc. And then you have an application controller which helps you to know correct number of pods are defined as well as like available again. Then you have endpoints controller, specific cloud provider controllers to interact with specific infrastructure, like say EBS or Google related or Azure related storage information, etc. Now Now, in a similar fashion, Kubernetes is like the natural way to deploy, because there's a lot of things that are already there. And then people usually deploy applications and feel like, okay, we are set for scale. We can go ahead and improve this one to kind of like deploy and scale our applications or services. So therein when more and more tools have come in, and that helps you to manage the applications, manage the installations, deploy general purpose applications again. So Helm is like your package manager for kind of like Kubernetes. Helm contains Helm charts through which you can deploy a lot of these things. And then basically on top of all of this, then like an operator framework came up, which is from the I believe it's from the core OS. And then it's an SDK through which you would deploy an operator. Like operator is contains a bunch of controllers which helps you to manage, orchestrate general purpose application like Nginx or Redis, Elasticsearch, MongoDB, or Kafka, etc. So you could deploy something and use it like a native resource, infrastructure resource of Kubernetes, etc. So there are some confusions around this package manager and operator, etc. Like say how would they both look like in general? If you see, this is how an operating system and all the things upon the structure of operating system, etc. would look like. But here, if you see, where would the operator fit in? It fits below the Helm or the package manager of Kubernetes. Operator is running on top of the Kubernetes or along with the Kubernetes other controllers as a third party controller, and you could define this controller using and install it like an installer, and then you use that as with an API, etc. Just like kubectl get your specific resource, you could use it in a similar fashion. But it is a bit lower and but it is bit aligned with the Kubernetes itself, wherein a Helm chart is like a package manager that sits away and does completely different. So there is an operator hub to go and discover all the operators. So you could go and look at operatorhub.io, wherein you also find the Elastic Cloud on Kubernetes. I'll come to the name, why Elastic Cloud on Kubernetes, why not Elasticsearch on Kubernetes. But this is where the GitHub repo is, and you could go and look at the GitHub repo. Now, why the name Elastic Cloud on Kubernetes? As I said, that Elastic Stack, not just Elasticsearch, is an encapsulation of a lot of things over a period of time. There are many dev tools that have been come up, and it can ingest a lot of things. So there are many ways that people mold this technology to use it in different ways. And there are general mistakes that a lot of developers would do, or problems that they face kind of doing a lot of these. So what happens is the Elastic Cloud on Kubernetes creates a Elasticsearch service kind of a thing on Kubernetes, so that you could just install, then kind of deploy it naturally. And there is nothing specific, or there is nothing that keeps you away from your regular on-prem workloads or etc. So that's where the name comes from. It's a suite of everything that is there, and you could simply run it. It has a custom resource definitions which can deploy the Elasticsearch, Kibana, APM, AppSearch, and multiple of these CRDs, and then a set of controllers. It also obviously automates tasks like generating a TLS certificate, holding the secrets, and creating the Elastic user, etc., etc. So that's how the Kubernetes, like the operator for Elasticsearch works. So I don't want to only talk and not show anything. I just want to also show you something and give you an idea of how this all would look like. So I have a Kubernetes cluster that I'm running on GKE, and it's a simple cluster, bare bones, and I am not doing anything crazy here. I'll just use the the deployer here. I'm using the Cloud Shell to kind of deploy the Elasticsearch instance. So I have set up all the commands here, so that I don't make too many mistakes. So I'm just installing the the kubectl through kubectl. I'm just installing the operator, and then I'm gonna create this particular operator. And you could also look at this operator logs actually. You could also take a look at like how this the logs of this operator would look like. And because we are essentially installing the controller, we're essentially installing a bunch of creating a bunch of custom resource definitions, and that would be available. I'm running a bit latest version, actually, and then that's why you see some warnings. But otherwise, if you are following 1.20, if your Kubernetes cluster is somewhere around that 1.20, or in between 1.16 and 1.20, it should be fine. Let us quickly create a Elasticsearch instance. Now that we installed the operator, we could kind of like create an Elasticsearch instance. Now I'll create it, and I'll also try to explain you with what about this particular instance. So let me just increase the font size here so that you'll be able to see it. I'll also see if I could increase the font size. Yeah. So as you could see here, we have Elasticsearch resource definition, which is of Elasticsearch kind, and we are creating a service called Quick Start with the version 7.13.2, which is the latest Elasticsearch version. And I'm also deploying a load balancer parallelly, so that I kind of like don't want to, like, I want to expose that, and thereby I could ingest some data, and then I'm enabling some node specific details. I have only one node. Later you could change it and run it 3 nodes as well. So this particular instance is created. Now let me quickly go and show you like, how can I query what's happening in Elasticsearch like using this one. So I'll just go and click this. So I'm watching that the Elasticsearch getting deployed. So it is deployed and ready. Let us go and see if it has got the IP address as well. So if I see get SVC, as you could see, I already got. But what about the password? So I said that there will be TLS certificates as well as the secrets that would be created. By default, it's a secure deployment. So there is a way that you could go and get the password as well. It's in the Kubernetes secrets. I just got that into a variable called password. So let me show it to you. So you could use that directly, and then like like call the service. Now let us simply copy this IP address, and HTTPS 9200 will call us this particular password. So we need to copy that in ahead of the time, and then like ask, and then it says that okay, you could generate your self-signed certificate as well, which I haven't, but it creates something basic, and sign in, and then you could see that the service that is running, etc., etc. So this is how you could kind of like go ahead and like create an Elasticsearch instance. But that's not it. You could also create a Kibana instance and take a look at that. So I also have a Kibana instance that I could use. Let me quickly deploy that as well. So again, in the same manner, you have a Kibana type resource, and then like it is linked to the Elasticsearch reference that we have created, which is Quick Start. It is the latest 7.13.2 service, and I'm also adding a load balancer so that like I get an external IP as well. So let us quickly see again kubectl get Kibana and -w. So and then like you see that it is working and it's available and it's running. So again, let us try to run the service so that like we will get the IP address here. While it is loading, I would definitely kind of like copy back the password that I have generated, or I could do echo dollar password. So yeah, all good. Yeah. So even the Kibana and Elasticsearch pairing is done through the YAML file that we have given. And then you also have the username password configured here as well as a default user, so you don't need to worry about the security as you deploy this onto Elasticsearch. The entire documentation is there on the internet, and I mean Elastic Docs, and then you could take use of it. You could make use of it, and if you want to do some complex stuff as well, let me quickly go to the DevTools part. Okay, so as you could see, I could just ingest the data. I could say cat indices. So I made a mistake. Let me do this. So I see that have some sample indices and details here. You could also ingest data like create indexes, do a lot of that. It's as simple as it, and like it's like your regular Elasticsearch cluster. The only caveat that I tell you at this point of time is to kind of remember that the kind of storage that you would add to this cluster, because the general purpose Kubernetes cluster in any service like be it GKE, AKS, and EKS, or any other system, right? You would use a specific sort of like kind of storage, maybe which is not perfectly suitable for all sorts of workloads. Just see, like Elasticsearch would recommend using SSDs. So just see if you could get SSDs added, your performance would be very much different. And again, I'm using the defaults here, but then like it works. But then at scale, if you want to run a petabyte size cluster, I would recommend you need to definitely take a look at a lot of these things, because end of the day, it's also a system, and then it runs on another distributed system like Kubernetes. So you need to be definitely be careful of what you're doing. So I have some information and dashboards, and I've installed some sample data as we speak. And then let us quickly go and take a look at that and how it would look like. So it's as simple as the regular Elasticsearch instance, etc., etc. So yeah, so you could also like uninstall in the similar fashion. You could also uninstall, delete the resources, manage the resources, create different namespaces, change the defaults, and do a lot of stuff. Uh, in the end, I want to just communicate to you all that running stateful applications on Kubernetes is not specifically a science. It's an art too. Uh, so you need to like learn the art of like building the stateful applications. And then there are reasons and there are interesting talk as well in the conference about building a stateful application and what you need to do. So if you want to learn more about or get documentation, get related demos, like you could join this link, or if you want to join the community, please join community.elastic.co. We also have a Slack channel, elastic ela.st/slack. You could join there. If you have any questions, please put it in the Q&A bar, and I'm happy to take it. Otherwise, I'm available in the networking table. You could come and talk to me otherwise as well. Thank you for joining the session. Have a great day.
Kunal, I think you are on mute.
Not a single day goes by, when there isn't a single meeting that I'm a part of where I'm not on mute. Anyway, no worries. All right, that was indeed an amazing presentation that we had from Aravind. And in this particular talk, this is one of the talk that I'm the most excited about. It's an AMA session on certifications, and we'll be learning about there are so many Kubernetes certifications. For example, CKA, CKAD will be joined in the panel by Sayam, as you can see on the screen. So Sayam, he's a CNCF traffic port trainer ambassador. The list of certifications for Sayam goes on and on, which is CKA, CKAD, CKS. I work with Sayam as well. So currently, he works as a director of technical evangelism at Civo, with a focus on defining the Civo cloud platform for simplifying Kubernetes and making it accessible for developers. And I'll let Sayam, talk more about what he enjoys doing as a hobby later on. Another person who is going to be joining us in the panel is Nipendra, who is the founder and principal consultant at Cloud Yuga. He's a CNCF ambassador and a certified Kubernetes administrator. He co-authored the Introduction to Kubernetes course for CNCF on edX. So make sure you check that out in case you're interested in learning more about the Kubernetes, and which has now been taken more than 180,000 users around the world. So super excited for this session. It's going to be a live interactive session. So first of all, thanks a lot for joining, folks, and really looking forward to it. For those of you who are joining, I see around 230 plus people have joined. Feel free to ask your questions in the chat. This particular session is also being streamed on YouTube, so you can ask your questions over there as well. But yeah, how is the day going for you all? How are you liking the event so far? Let's start with Nipendra.
Yeah, guys. So it's been awesome to be part of this event. Before being a part of the organizing committee, but as a part of this day itself, right? Just a way of tremendous response what we're getting all over the thing. And again, thanks to all the speakers, presenters who is kind of making it really kind of interactive and not feeling like that we are somewhere. The recorded videos are running, right? It's kind of happening pretty awesome. And then thanks for you guys to kind of running the show. Yep, pretty good.
Yeah, the sessions are going really well, as Nipendra mentioned, and the organizing team has put a lot of time in organizing this so that it can be streamed smoothly. And we are now switched to 1080 as well. So I think everything is going smooth, and people are interacting very well on Slack, on Bevy platform. So I think a lot of interactions. There's networking room. People are over there. The speakers are going to the networking room, and you can have a chat and word with them as well. So really excited, especially for this session, because that is something that Nipendra has been doing for a long time. Now I also have been doing for a long time. So certifications is something we get a lot of questions for, and we thought let's do a live kind of Q&A session for the folks. So yeah, really excited for this.
Cool. So let's kick off the particular talk. Maybe we can start by discussing about why certifications. Why in the first place would anyone want to get those? So maybe Sayam, you can start, or anyone.
Yeah, I mean, so Kubernetes certifications, first of all, are one of a kind. So it's not something like the MCQ kind of like you get a question and you get multiple choice and you select the answer. So it's a complete hands-on, exam where you get a proper terminal, and you'll be getting a different set of clusters. You'll be getting problem statements, and you'll have to solve them and get a certain output. Sometimes store certain output in a particular file. So there are a lot of scenarios. And that is where Kubernetes plays the certifications of Kubernetes plays a very important role. Now it also helps you learn, because when you are practicing all these things, there's a learning curve involved, and you will be learning a lot of things because you'll be practicing a lot, because the exam is like that. So you have to have that specific knowledge. You have to be well versed with all the kubectl commands, like kubectl create, deployment, kubectl run, nginx -hyphen image nginx. You have to know some of the tricks while you are typing, so that you're fast, because these exams are really time bound. So most of the common feedback is like they didn't get time to complete the exam. So that is very important. So obviously when you are at that level giving the exam, so you have gone through that learning curve, so means that you will be having that sort of knowledge. So that's where the exams plays a very important role. And obviously certification adds credibility to your resume as well. So you will be like you'll be getting a fancy badge, and you can show that you are the CK, CKD or CKS certified.
Yeah, if you have been old enough like me, right? I don't know if you have given these RSC exams, which has been like so popular in 2007, 8, 9, is still there, right? So if you have taken those exams, right, to become an RSC certified was like a dream, right? So those exams were there. I mean, still there right now. I'm not saying that. It's just that there's like a passion about it, like that you need to pass the exam by doing the hands-on. And I think what these certificates are giving the same opportunity for you guys to basically that you get the same satisfaction once you kind of give the exam. It's not just about clearing it, but going over the process, clearing it is definitely kind of makes it more attractive. And is it must or not? It's depending on your experience level, right? So if you are kind of a bit experienced person, then you might say, no, I worry about the knowledge perspective. I don't care about certification per se, right? But if you are kind of somebody who's kind of want to change the field, or if you are a student who want to kind of get an extra thing right in your resume kind of a thing, that's where it could kind of makes much more sense there to get certified. So it's must for people at least who want to change their field, who want to kind of change the ladder. But if already experienced person, you are kind of mostly eager about the knowledge, not for certification sake. So yeah.
Thanks a lot for sharing. And there's a follow-up question on that by Sarye. I believe I pronounced that correctly. So it's a salary question. How much salary increase can I expect if I manage to earn a CKA certification?
Okay, that's a tricky question. It depends on see, nobody will pay for certification. It just kind of gave a way to get you an interview in a way, right? It's like if there are 20 resumes, 5 resumes are for the CK certified, you might get preference over that, right? Then once you are in that interview, how you would do it, what's your previous thing, everything counts there, right? It's not that you give me a number, I get certified and I get 20% hike. Yeah, most likely that's there, but no, there's no somebody can tell you, okay, you're certified, you get X percentage hike. Nobody can guarantee you that. Yeah.
Sangam, what do you think?
Yeah, I completely agree with Nipendra. Like, this is kind of a question that depends, region to region, company to company, person to person, experience to experience. So everything would matter. Your region would matter. Your company would matter. Your position would matter. The level at that you are getting interviewed for, obviously that slab would matter, and your previous salary would matter. So everything comes into place, and yeah, it definitely helps you getting shortlisted. Because if you see the LinkedIn kind of process, the how they process the resumes, obviously I told you, like CKA or CKD or CKS, they add credibility, because when you have cleared the exam, that means you have gone through that learning curve. How to write, how to spin up a cluster, how to run pods, deployments, etc., etc. So all that things. So that's where, I mean, people would assume that this person, X person, has X amount of knowledge already, so they are the best fit for the at least for the interviews. Now after that, when you're sat for the interview, it again goes like on the base of scenarios that they ask. Like they might ask you to do something practical, they might ask you scenario based questions, we don't know.
Yeah, the most thing that matters is do you have the real world experience or not? That's going to be the critical thing. I mean, certification is definitely, it's going to be an edge, but everything matters about how much practical you can do things there.
Thanks a lot for sharing. And we have another question regarding these certifications we briefly talked about. So the question is being asked by Fagun and Nikunj. So what is the difference between CKA and CKAD? Considering we are not going to install bare metal Kubernetes because we have like AKS, GKE, or AWS cloud provider has installed like the manager for Kubernetes is available.
Yeah, so nothing hurts even if you know more, right? So, I mean, if the CKA is nothing but CKAD plus some content for managing cluster, how do you manage the cluster and so on. So CKAD must any for CK as well, right? So CK is equal to CKAD plus something extra, right? So CKAD is must, that anyway has to happen. Post that, would you want to go for the installation part and so on? If you're just talking about certification, okay, there are two ways to look at it, right? One is if you are just trying to learn a knowledge kind of a thing, right? Then you might just skip the installation part there, right? But if you want to get certified, then of course that's a must, right? You can't skip that. So in that scenario where you don't have a must, just stay with CKAD. But if there's a must, you want to go for thing, then you can learn about that stuff there.
Yeah, and also like it depends on the future certifications as well. Like we have CKS now. So for CKS, there's a requirement that CKA you have to be certified. So again, you have to take that route if you know you have the security involved. You want to make your cluster secure,
Yeah.
or you already have that knowledge. You want to validate that.
Yeah, most definitely. And there's a question regarding like that only. So the question is, what is the gap between training for the CKA and a real world day-to-day Kubernetes cluster management? It's a good question.
I can take that first. So when you talk about real world scenario, how that works is basically if you are, from a clusters admin perspective, suppose you want to set up the infrastructure first. So you'll be either choosing bare metal, or you'll be either choosing your, virtual machines in some of the cloud providers, or you'll be going the managed routes that was mentioned in the previous questions, like the managed Kubernetes offerings. So if you are setting up your own cluster, then probably that comes with your, you are using cluster API, using kubeadm, and all those setup techniques that you can spin up the cluster. So that comes under the administration part, that comes under the CKA perspective. And then you will be having your the monitoring aspect that you want to have on top of your CKA, on top of your cluster setup. So basically you'll be deploying the applications. So that comes under the actually both. So CKA, CKD, they both have the Kubernetes objects, because you have to know what are pods, deployment services, because when you create applications, you'll be deploying it as your deployments, stateful sets, and exposing them as services. So that comes the second part. Third part would be the Kubernetes troubleshooting, which also has a portion in your CKA. So Kubernetes troubleshooting that you'll be doing, so exec into the pod, see what is happening. So all these things, getting the logs. So all these things are also part of the certification. So yes, they are tied to the day-to-day tasks, but obviously when you are in day-to-day, the curriculum is very specific to certain portion of the concepts that you should know, whereas in day-to-day life you will be doing more production ready stuff, which will require you more of the configurations that are not part of your CK, CKD, or even CKS, but you will be having that knowledge. You will be able to do, because you already know all the concepts, you'll be able to apply them, configure them, change them as per the needs of the project or the organization.
Every company has different way of doing things, right? So I've been training in different companies, and I know that every company has a different way of doing things. So, and you can't put everything in the exam, right? So the exam is only to kind of give you a basic, again, like a token, right? That, okay, you know something, right? But once you kind of go to the real world, it's way too different than just the exam. Correct, because every company has way of authentication, right? Every company have way of logging. They use different software, different stacks are there. Somebody on AWS, somebody on Azure. So you really kind of say that, okay, exam can give me feature of and feel of everything. It's Kubernetes, along with, you should know all the peripheral stuff, right? A cloud stuff, right? Maybe at least you need to know about one cloud in detail, not everything. If you know one cloud in detail, you would know basically how does the cloud works, right, in general, and you can just apply that knowledge anywhere, and that would kind of give you a kind of a say more edge there.
Thanks for sharing. We have a question from Kishore. which says what someone should do after getting CKA and CKAD, how to get a production grade experience, how someone should proceed. Orgs are asking more on production grade experience.
Yeah, so few things to look at is, I mean, there are a couple of ways to tackle that problem because once you get certified by some, I mean, you learn and you do that, right? But still, you need to switch your job, right? And that will not happen easily. So there are a couple of ways to do it. One is you basically make yourself kind of available to everybody by putting maybe, let's say, blogs, some LinkedIn things, and so on. That will give you some eyeballs to your resumes and so on, right? And then maybe do some fun projects in a way, like, or join any of these open source projects like OpenEBS and so on, right? Look at their issues, what they're facing, and then try to do that, or have those companies volunteer for them. So okay, I'll basically try to work with you and maybe write a documentation for a given stuff. Company would love that because everybody have a crunch of resources, and then if you can step up, it might lead to a better outcome for you. And of course, practice. I mean, how would you practice post the exams there? uh, I think by learning to these meetups, coming to these groups and so on, where people come and share their knowledge, that will give you a kind of a feel what's happening, and then at least try to mimic that scenarios locally. Let's say yesterday we did this Argo CD thing, right? There are some students were there, right? And the comments were there. This kind of, I got to learn more than what I could have imagined in the college days, right? So what's happening in the thing? So at least a problem statement. So first figure out what's the problem people are trying to solve, and then you can write your blogs accordingly. That would help you out.
Yeah, that's I mean, I absolutely agree to the points. Like, you have to be very much involved in the community. So you have to write blogs, you have to be presentable after your certifications, and you can think of scenarios like how to set up Thanos with Prometheus for long-term storage. So you can write a blog on that, and people need that for production ready. Like, if you scale and if you need long-term retention for your metrics, you will need kind of a certain extension to Prometheus, a storage solution. And so you can have that set of blogs and you can try that out. So that gives you a feel. Again, you can do kind of you can choose different cloud vendors, you can choose different instances size, set up a master HA kind of Kubernetes setup. So that again gives you a feel of how Kubernetes in a HA kind of environment works. So you have to try it out. Obviously things won't work immediately. You have to see how the CIDR ranges works, how the networking stuff works, because those are the things that gets complex when you work in the real world scenarios. So you buy a domain and point your domain to certain add certificates to it, point your domain to the application that you are deploying. So all these things really get important, and blog about them, create a front end and a back end application, containerize that, deploy that, see how it works. Create a stateful application, see how you can persist the data, use the open source solution like Longhorn, OpenEBS and all those, see how you can persist the data using the storage solution. So these are some of the examples. There are tons more examples that you can think of, and again, blog about them and learn that. So it will build your social profile, it will build your get you, like Nipendra said, it will get more eyes on you, like, okay, this person is doing a lot of great work, so he's having experience in this, he's having experience that. So that would give you kind of an edge after the certifications.
See, that's what, even if you look at, there are ambassadors here, right? How we kind of get it there, right? By involving by the community, writing the blogs, talking to people. That's the only way. Basically, so there are two ways to look at it. One is you look at the contribution perspective, right? So contribution can happen in different ways in the community here, right? One is you really write the code and be in that thing, or you help yourself along with the community learn together. That's also one way of doing it, right? So it's kind of open a lot of doors for you. You never know. So anyway, certification or certification, don't bother too much about it. Come some way online, make yourself available. That's the biggest thing.
Most definitely. And we have a question over here regarding some job interviews for like startups that they have come across. Some hiring managers who don't really, value certifications that much. For example,
Correct.
they feel like that what they want is someone who actually has some experience versus just having certifications. I know we did answer like how that relates with the real world, but the question is that how would one move jobs when hiring person where hiring person ignores certificates. So can we get production level experience with these examinations, or if there are any resources you would like to share?
So I have seen two kind of people, right? One is basically who is part of which is just out of the college, and somebody who want to switch their career. So I have seen people who have been there for a while in the industry, let's say 20 years right now, 15 years and so, right? And now they are finding it difficult to switch because they have been ignoring by kind of say by intentional or by non-intentional, whatever it is, they've been ignoring what's happening around them, right? So they were kind of focused on their thing, right, and then doing it. Now, what happened with that is that's a more difficult thing when you already have a higher package and you want to shift. That's greater risk than compared to for the newbies, right? For newbies, I would just say, just go and say, I want to work as an intern with you for any company for 6 months, right? Something like that, right? That's the easiest way you get the good knowledge. And I have done it a couple of times in my company. We take interns, we kind of pay them, of course, in some way, but they get to learn the real stuff, what's happening, or at least what's coming in the community or in the real world scenario. So if you are newbies, very easy. Go to any company, say, I want an internship, don't pay me anything for 6 months, that's it. You get your experience, either they'll hire you, you'll get somewhere else. That's the easiest way for you to get in the real world. But for the people who are experienced person and they want to switch, for them, the only way out is to figure out some contacts or showcase their current knowledge. So, for example, if somebody was in testing and now they know that Kubernetes is coming or whatever, right? They have to kind of combine that knowledge somehow, tied together, and showcase that, okay, you can take your current knowledge and do it and then take it forward. But the question was one more point you had, right? If a hiring manager doesn't care about certificates, then the only way you can have is by showing your GitHub profiles, get your course content or whatever the content you can show the things, what you have done. That's the only way. You can't do any other way stuff, right? So there is no other way you can do that. And to get the experience, I think the internship is the best one. Just figure out, like you will see a lot of companies in the CNCF members, right? Just write to them, I want a internship, would you give me something like that? Yeah, that's the way. That's what my suggestion would be. But yeah, there are a number of paths to kind of reach the destination.
Most definitely. And I just also want to share that we have the a scholarship form that I've shared in the Slack channel for the CNCF Cloud Engineering Bootcamp, in case you're interested in that. So just fill out that particular form. Cool. I believe we have a few more questions. Just 1 second. Okay, so the question is regarding the preparation. So how would you go ahead with the preparation part of CKA, CKAD?
Go ahead, Sam. You can take this.
Yeah, so there are tons of ways, and I'll share the screen as well with some of the resources, some of the links that I've already opened. Let me know if you're able to see the screen. Okay, so basically, this is the first place that you should come to. This is the curriculum, and I think Nipendra was involved in the new CKAD curriculum as well. So basically, the certification gets updated for the newer Kubernetes versions, and the questions get updated, and a lot of people get involved from the community, from the ambassadors group. So that's how the exams are created. A lot of trainers get involved. So like this, you can see there are different curriculums, and right now the CKA, CKAD, they both have been moved to v1.21. So again, you cannot prepare for 1.18 and then some commands do not work. So you have to first go through the curriculum and see what all topics are there. Now comes the preparation. So first there is like the Linux Foundation official courses that you can take. Then there are some of the open source repositories like Kubernetes Certified Administrator. So Walid and some of the folks, they maintain very good repositories that covers all the objectives with some of the links that either point to a lab or they point out to some resources, some books, some YouTube videos, and all those things. So they are very much appreciated in the community. I have seen, and even the tips section, you can see there are tips, a lot of cheat sheets that you can remember, a lot of aliases that you can use. So there are a lot of tricks that are also mentioned that you can have a look at. And same goes for certified Kubernetes security specialist. Fairly new certification, people are very excited about it, and the prerequisite for this is CKA. So make sure you check out this repository as well. Very much content rich. This particular repository is. All these sections are mentioned, and all the links correspond to one or the other tutorial book and other stuffs. Another thing is that there's a exam simulator which is killer.sh. So recently CNCF has announced with each certification that you buy, you will be getting two simulators for killer.sh with respect to the certification that you have purchased. Now this is basically a complete exam like environment that you will get. So you'll get same kind of feeling when you are doing the scenarios. So this comes free when you buy the certification vouchers. And as of now, if you apply the coupon KCD 2021, you get 20% discount across all the certification and the training courses. So that is only for this particular KCD Kubernetes Community Days Bengaluru. Now there are other other what you call resources as well. Like there are courses from A Cloud Guru. They recently launched CKS course, and I think Cloud Yuga also have a lot of resources. So Cloud Yuga courses. So so Nipendra runs Cloud Yuga, and he obviously he's the instructor, and there are a lot of courses on Cloud Yuga as well. So we can explore all the courses. You can see the container fundamentals, Kubernetes administration, developer. So all these courses are there. Then you have Mumshad's Code Cloud. So that also, like CKS course was just launched, and CKA, CKAD, they always get updated. So I think there are a lot of courses that you can go through. Now these courses go in depth, and then they have mock exams, practice exams that will help you to prepare to give you the exam kind of feeling. And the killer.sh will comes free with your whatever you have whenever you purchase the exam. Also, like for the CKS, I also wrote a book on Let's Learn CKS scenarios. So this is only for the security exam book. Again, the same coupon of KCD 2021 applies to this book as well. So if you purchase, you'll get again 20% discount. So these are some of the resources that you can do. Now, two most important things that from CNCF that we are kind of have started. One is the Certs Magic Show with Sayam, with myself. So we have started a Certs Magic Show, which runs bi-weekly on Thursday, 8:30 p.m. The first episode just went aired last Thursday. It is just about, like, I gave the high level view of what certifications are and what are the agenda and all that. We will be preparing, and I'll be going live with some of the instructors, trainers, and other folks who are actually involved in making those certification exams. And we'll be discussing some of the sections where we'll be discussing some theory, and then we'll be doing some of the live scenarios. So make sure you subscribe to cloudnative.tv. It's official CNCF channel that is there. And Certs Magic with Sayam is the show every bi-weekly Thursday, 8:30 p.m. that you can join. And if you join live, we do 2 coupon giveaways on each of the shows, which is 50% discount coupon on the certifications. And another thing is, like, there is a webinar on especially for CKS that I'll be doing on 22nd of July. This will be by Sysdig, so you can also join that. So basically the whole agenda for showing you all these resources there are tons of resources. There are tons of free repositories, then there are few paid resources as well. And all these courses like Nipendra courses or Code Cloud, they are very valuable because they teach you everything from scratch. So if you if you don't only want to practice on killer sh and you want to go through some concepts as well, so then these courses definitely help you learning all these concepts from beginner to kind of a certification ready person.
Yeah, one more thing, of course, is documentation of Kubernetes, right? Kubernetes docs are really good way of doing that. The only thing missing there is the flow, what I see that, right? Because if you go to that documentation, they might not follow the flow of the exam perspective, but the content-wise is very rich. So, I mean, you can just skip all the courses and everything, you can just focus on the Kubernetes documentation itself and go each and everything, at least for dev and the CK exam, you will find each and everything there. Because the CKS exam, I think, contains some other tooling as well, which is not part of main Kubernetes thing, Kubernetes code or the documentation. So that you might learn on your own maybe or figure out. But you don't need to spend any money. Just look at the documentation and look at the syllabus, match it, and you can very well do it.
Most definitely. Well, thanks a lot for joining, Sanyam and Nipendra. Really appreciate it. And I believe we answered most of the questions that we got. And just one last thing for everyone who is joining, if you have more questions, make sure you check out the CNCF Slack. And yeah, Nipendra, go ahead.
I just have one more point to make here, right? People like we get kind of so nervous to give the exam perspective, right? And exam might be too difficult. Just remember one thing: so it's a complete ecosystem, right? Like Kubernetes, CNCF, members of those community, they want you to get certified. They would not make the exam so difficult that you can't clear the exam. So companies want more people to get certified. You want to get certified, and there has to be a match, correct? So the exam is not trying to make you like take kind of make you a superhero kind of a thing, right? You are there to just kind of be that common denominator, right? You just kind of pass that first hurdle of that, right? That's the exam, correct? So don't get too nervous. They want you to clear the exam as long as you know just enough, right? So exam is just a first step, right? Yeah, that's all.
And also you get two
Totally agree,
attempts
yeah.
for each exam you buy. You get two attempts to to clear the exam.
Totally
So
agree.
that's also where they have made it kind of easy. So if
Yeah.
you cannot clear in first attempt, you get the feel, and the second attempt also you can take and give the exam.
Most definitely. Some really nice insights shared in this session and would really help a lot of people, including me. So thanks for joining, Dipendra and Sayam. Really appreciate it. I just want to share that after this session, we have a little bit of break, and at 1:40 p.m. IST, we'll be starting with our keynotes for the afternoon.
Thank you,
Cool.
guys.
That's all fuel up, and yeah, see you after the rest break. Bye.
Bye.
Hey everyone, how's it going?
Hi, welcome to Learn Kubernetes with Google. My name is Aldo and I'm a software developer in TKE.
My name is Isabel and I'm a cloud engineer in Google Cloud Professional Services.
I'm going to teach you about the Kubernetes Gateway API.
Switching to Containerd as the container runtime eliminates this middleman.
Let's look at them. So as above,
Hey everyone, hope you're having a great event. And now it's time for the afternoon keynote session. So the keynote we have right now is from Janaki, and Janaki is a practicing architect, an analyst, and advisor focusing on emerging infrastructure technologies, backed by 2 decades of experience at Amazon and AWS and Microsoft. He provides strategic advisory to technology platform companies, startups, ISVs, and enterprises. As a practitioner working with a diverse enterprise customer base across the domains of AI, IoT, cloud, microservices, DevOps, and SaaS, Janikaram gains insights into the enterprise challenges, pitfalls, and opportunities involved in emerging technology adoption. He's an Amazon, Google, Microsoft certified cloud architect and a certified Kubernetes administrator and a certified Kubernetes application developer. He's also a CNCF ambassador, a Microsoft MVP, Intel software innovator, IBM champion, and Microsoft regional director. I am truly super excited for this particular keynote. And without further ado, let's get started.
Welcome to this session on the transformation of Kubernetes into a universal control plane. My name is Janaki Ram. I'm a CNCF ambassador based out of Hyderabad. I'm a Kubernetes enthusiast. I hope you're having a great time at Kubernetes Community Day, Bangalore. So let's get started. I have a pretty interesting set of items in the agenda. I'm going to start off with the evolution and the background of control planes, followed by a closer look at Kubernetes control plane, and then extending the Kubernetes control plane to transform that into a universal control plane. Towards the end of this session, I'm going to leave you with some examples and evidences from the ecosystem where Kubernetes is orchestrating resources that go way beyond containers and pods. So let's get started. Control planes are not really new. If you look at the operating system, it is actually acting as a control plane, particularly the kernel. It is orchestrating the processes and threads and making sure that they are optimally utilizing the underlying CPU. Back in the days of J2E app servers, we had EJBs that were orchestrated by the app server and placed in one of the application server instances. The unit of job was basically a EJB, and the runtime was, of course, the JVM. And
Okay, I guess we are good, and then we're starting the track one here. Uh, the first talk is about GitHubs with to manage the life cycle of cloud resources with Argo CD. We have the speaker Ravi Hari here, and then who is available to take more questions. If you have attended his Argo CD workshop recently, it was really amazing. And I don't want to delay further, and I just want to get started quickly and share everything. Okay, here we go.
Hi, my name is Todd Eckenstam, and I'm here with Ravi Hari. We will be discussing how to use GitOps to manage the lifecycle of cloud resources with Argo CD. First, I'd like to go over the high-level agenda of what we'll cover in this talk. We will briefly explain what GitOps is, some of its benefits, and why it's a good fit to be used with Kubernetes. We'll discuss the controller pattern and introduce some of the open source controllers that can be used to manage cloud resources. You'll also learn how Argo CD can be used to deploy cloud resources using those controllers. Next, we'll walk through how a custom tool in Argo CD can be used as an alternative to Kustomize or Helm to build a custom project format. Last, we'll wrap up the talk with an end-to-end demonstration of deploying cloud resources using Argo CD, as well as a discussion of our experience using GitOps add into it. If you signed up for this session, you may already be familiar with what GitOps is. But for those of you who aren't, GitOps is a process that uses a Git repository to store the desired state of an operational environment and a GitOps operator to perform the operations needed to make the actual operational state match the desired state. It's really a mechanism for doing DevOps. Instead of making changes directly to the system using a UI or a CLI, changes are made to those configuration files representing the desired state in Git. The GitOps process would start with someone on the team creating a branch and submitting a pull request containing some changes to the desired state of the infrastructure. Those changes can then be reviewed and approved using standard revision control processes. Once changes have been approved and merged to the main branch, a GitOps operator, such as Argo CD, is responsible for changing the system's current state into the desired state based on the configuration stored in Git. In an ideal implementation of GitOps, manual changes to the system are not permitted, and all changes to the configuration must be made through files stored in Git. GitOps provides many benefits to developers since it allows them to treat the configuration of infrastructure and deployment of code in a very similar manner to how they manage their software development process. Infrastructure as code means that infrastructure changes are represented as code, and the source code for the infrastructure is stored in a version control system like Git. This enables repeatable deployments and prevents runtime issues caused by configuration drift or missing dependencies. With GitOps, development teams are empowered with self-service deployments instead of being dependent on an external operations team. And once the DevOps engineer can treat infrastructure as code, the logical next step is to perform code reviews on the infrastructure changes before deployment to make sure they are correct. In this case, the code being reviewed may primarily be Kubernetes YAML manifests or other declarative configuration files, not really traditional code written in a programming language. Now let's look at the operational benefits of GitOps. One of the more prominent paradigms to emerge from the DevOps movement is the model of declarative systems and configuration. Simply put, with declarative models, you describe what you want instead of how to get there. Observability is the ability to examine and describe a system's current running state and be alerted when unexpected conditions occur. With GitOps, you can easily compare the desired state of the system stored in Git with the actual running state. Since with GitOps, all changes are revision controlled, auditability, compliance, disaster recovery, and rollback are all made much easier. Sorry for the shameless plug, but please check out the GitOps and Kubernetes book if you'd like to learn more in depth about GitOps. Now let's talk about how the GitOps operator such as Argo CD actually works. The GitOps reconciliation loop begins by cloning the repository to fetch the config repo's latest version. Next, the manifest discovery stage looks for any Kubernetes manifests to apply to the cluster. This is where a tool like Kustomize or Helm is run to transform the directory layout in the deployment repo into rendered Kubernetes YAML manifests. This is also where you can run your own tool to render the YAML instead of Kustomize or Helm, and we'll see a little bit more about that later. Lastly, the kube control apply step performs the actual deployment by applying all of the rendered or discovered manifests to the cluster. So apologize if you're already familiar with this, but Kubernetes operates using something called a controller pattern, where there's multiple controllers in the cluster that are really just running as pods inside the cluster. And these controllers are looking for creates, updates, or deletes on a particular type of resource. And a resource is defined by some metadata, a specification, and status. So the controller will look for updates on these resources and then attempt to reconcile that resource so that the configured state, desired state, matches the actual state. And that might involve making some Kubernetes API calls or some other operations. And once that's done, then the status of the resource is updated. So this is the way a typical Kubernetes controller works. Now, however, there's nothing to stop a controller from making external API calls outside the cluster. So for example, we could have a controller that makes SDK calls to AWS or GCP. So this is really where we're talking about managing external cloud resources. This is the mechanism to do that within Kubernetes. There are several open source cloud resource controllers that can be used with GitOps and Argo CD. The AWS load balancer controller is fairly mature with a V2 version recently being released. It allows management of, well, you guessed it, load balancers, very aptly named. There's also Crossplane, which supports multiple cloud vendors and multiple types of resources. And then AWS controllers for Kubernetes, or ACK for short, which is a collection of controllers for various AWS managed services. This project is still fairly new and not many are claimed to be production ready, but there's a lot of momentum behind them. However, at the time we started this project, Crossplane and ACK didn't exist. So we did what any other self-respecting development team would do, and we wrote our own controller. So we came up with, but what we wanted to do is we wanted to manage CloudFormation stacks using a Kubernetes controller. So we wrote a custom controller called Cloud Resource Manager. This was a pretty straightforward controller in the sense that it just did one thing. It processed CRs that represented a CloudFormation stack and created those stacks on a target account. So here's what an example CR would look like for a cloud resource deployment. In this case, we're creating an S3 bucket. This first section in the spec, the assume role provider, this is used by the controller to manage the connection to the target account and assume the necessary role to actually create the CloudFormation stack. We'll talk a little bit more about that in the next slide. Then this next part, these are the parameters. These are the parameters, the region, the stack name, the template. These are all the normal things that you would need when calling the CloudFormation SDK. So these are things that are actually passed into the CloudFormation SDK. And then you can see the actual template itself. And this template is fairly simple, but you can imagine you can also have fairly complex templates as well. The controller doesn't really care how simple or complex the template is, as long as it's a valid CloudFormation template. However, there is some usability issues when you start getting very big templates. And also at Intuit, we very rarely have a custom template that's used only once. We typically make patterns of templates, patterns of CloudFormation templates, so that we can reuse them and version control them and kind of keep them in a central place. So we had another effort to address that aspect, which we'll also talk about in the next slide, which is to create a custom tool for Argo CD that lets us represent lets us basically reuse these templates and generate dynamically generate these CRs from a project specification directory. So now let's talk about how to deploy cloud resources with Argo CD. And again, in this case, we're going to be deploying a CloudFormation stack. So it all start with a user making some configuration change, making a PR, submitting that PR, merging that to the main branch of the deployment repo. And Argo CD is, you set up what Argo CD calls an application. You set up an application in Argo CD that's watching that particular repository and a particular subdirectory in that repository. And when it detects any changes, it will call some tool. Usually it's Customize or Helm, but in this case, we're calling a custom tool called Manny. And Ravi will mention a little bit more about Manny later, but this is really our custom tool that we've installed into Argo CD that lets us represent a custom project hierarchy in the deployment repo. And it kind of takes the place of Customize or Helm in this kind of workflow. But whether it's a custom tool or Customize or Helm, regardless of which tool you're using, the end result is a series of YAML files, a series of Kubernetes manifests that are then can be applied to the cluster using kubectl apply. And that's essentially what Argo does. Then when the kubectl apply is done, that's going to create one or more CRs based on those manifests that were discovered by the tool. And in this case, it's going to create a CloudFormation CR. That CloudFormation CR is going to be picked up by the Cloud Resource Manager. Inside the spec of that Cloud Resource Manager, it may contain information about what cross-account role to use to deploy this resource, in which case it will use that cross-account role to create the stack in the target account. When the stack is created, it's also passed a service role so that the CloudFormation service would use a specified service role that would then create the actual objects in the AWS account. And that service role can be targeted to the types of resources that you want to manage using GitOps. The cross-account role is a very targeted role, only having permission to manage CloudFormation stacks. So it's a very limited role. But then from there, you can create any type of AWS resource that can be represented in CloudFormation. But this is what I really want to talk about. We are announcing here at this conference the open source contribution of the Cloud Resource Manager under KCoproj. This is a new Kubernetes controller developed and maintained by Intuit that manages the lifecycle of CloudFormation stacks. We're also looking for users and contributors who want to participate in this project. And the URL is here on the screen. I encourage you to go check it out. Ravi is going to give us a more in-depth view of the Cloud Resource Manager and give a full end-to-end demo of how you can use Argo CD to manage cloud resources in a GitOps manner. Ravi, take it away.
Thanks, John. So the Cloud Resource Manager is now open source, and the kicker parts, please try it out and let us know your feedback. It's a Kubernetes controller built with kubebuilding. The custom resource for this controller essentially embeds CloudFormation stack into it. So whenever the custom resource is run, it will look for the corresponding state of the stack in the AWS. And then the controller would determine based on that state, whether to stop the reconciliation or re-queue for reconciliation of the custom resource. So we identified a bunch of states for CloudFormation stacks, and we grouped them into two buckets. One is intermediate states, and the other one is terminal state. Whenever the stack lands into the intermediate state, the controller would update the status as in progress for the CR, and it would re-queue for reconcile. If the stack lands in one of the terminal states, it would update the status accordingly if it's a success or failure and stop the reconciliation. Let's look at a live demonstration for this. So the custom resource for this would look like this, where the kind is cloud resource deployment, and this is the API version. You can update the fields. It would embed all the CloudFormation information in this spec, and the template for the AWS CloudFormation is given here. It would pick up the parameters and other things that are passed in the parameters section of the CR spec. Now, we can see this view in Argo CD. So we configure the application by passing in the repo URL, the namespace in which we want to deploy these resources, and the path in which in this repo the custom resources are present. We see that the desired manifest is generated by looking into the content in the GitHub repo. Live manifest is empty because we haven't yet submitted this into the controller. One of the things that we have noticed is that having to put this CloudFormation template in every resource is because this is too verbose. It would be an overhead for the engineers to maintain this in and review it and stuff like that, as it is too verbose. So what we have come up with is we thought of grouping all the common things into one particular block and move the common templates into S3 buckets and download them at the time of creating this CR. So what we have done is we put all the common configurations like account number, environment, region, and all these things into the config YAML. And the core content for the custom resources, like the template, the CloudFormation template, we have put it into S3 and we have declared that it's a type of S3. And then we have passed in the parameters that this template would use. With this, it looks like a scepter kind of configuration management, right? But scepter would ideally create the resource as well. What we wanted to have is, based on this information, it should merge all this data and generate the custom resources that the controller can accept. So we've created a custom CLI, and we have configured this custom CLI in the Argo CD. The way we can use this custom CLI in the Argo CD is, this content is same. All that we need to modify is the manifest section, where we update the name of the plugin that we want to use to be Manny, which is a CLI that we have done. So we update this plugin name to be Manny. That way, whenever the Argo CD repo server, which actually reads the data from the GitHub repo, we execute this CLI command and translate all the configuration files that we have here into custom resources that the controller can understand. Now, if we look into this desired manifest, this is similar to what we have seen for S3 bucket configuration in this earlier app, right? So essentially here, we haven't used any CLI configurator. It is directly using customize. Whereas in here, we have configured our own plugin CLI, and we translated all the configs that we have declared into here, which are much simpler to manage and review. And those are getting translated into custom resources that the controller can understand. So this is a flexibility that Argo CD gives. We should utilize it if our needs match to this one, right? So now we can go ahead and sync these resources and see if they're coming up in the actual cloud account or not. So we've seen those resources. Yeah, so they are in progress now. As you see, there is a progress bar that's spinning, and the cloud resource is in progress. And we can also look at the events. So it started creating the chain sets. So we should see the events, the stacks getting created now. So these are all the stacks that we are creating: S3 bucket, NACL, and the security group. So it looks like the security group is already completed. So as it landed in the terminal state, we would have seen this one landed in a healthy state. So this is landing in a successful termination state. So we see that this is in a healthy and there is a healthy heart symbol. We can look at all the events that this CloudFormation generates in the Argo CD events itself. We do not have to log in into the account and watch it always. I was just showing this so that we see that the resource is actually generated and we could see the security group actually getting created. So like this, we can create all the cloud resources that we are interested in. We don't have to limit ourselves to these three, but VPC, VPC endpoints, VPC peer rings, transit gateways, any sort of AWS cloud resources that can be created with CloudFormation stacks, we could create with this controller. So this is the security. Right? Now, we have seen how we can configure the custom CLI in the Argo CD UI. Let's look at what needs to be done in order for us to be able to use this custom configurator in the Argo CD while deploying Argo CD into the Kubernetes cluster. So this is a representation of what we have seen in Argo CD UI. So this is where we need to make the changes. We need to look at the Argo CD repo server deployment object. So we download the content of Argo CD deployment from the open source, and we edit the section where there is this Argo CD repo server. What we need to do is we need to introduce an init container, and this init container should download the mani binary, and then we volume mount this binary into a specific location. We need to use this volume mount in the main container of the Argo CD repo server, such that this CLI is available in the Argo CD repo server pod to be used by the Argo CD when it reads the data from GitHub repo. This is one part of it. The other part that we need to configure is what action it should do whenever it reads the data from the GitHub repos, right? So we need to configure that in the config map of the Argo CD in the config management plugin section. So we need to declare that whenever the Argo CD repo server reads the files in the given path, it has to run this command, mani build.command, on all the files that are present there in that path of that repo. Like by default, Argo CD supports customize, so it runs a customize build.command. Then it merges all the files that we have declared in the customization YAML, and then it generates a final output, right? So similarly, in here, it looks up all the files that we have configured there, and it generates the custom resources as we have seen earlier in the Argo CD UI view. Now, this is how we configure the custom configurator CLI tool. Now we have seen that the Argo CD is qualifying the status as in progress, and it is giving us a spinning wheel when the TRs are in progress state, and when it is in a successful state, it is showing a successful heart symbol, right? So in order to get that, we need to update the resource customizations in Argo CD, where we have to embed a Lua script into it, and we need to update here that if the custom resource object status is in progress, we need to say that the object status for the Argo CD should be progressing, and the message that we see there should be cloud resource in progress. Whereas if it is in a success state, we qualify that as a healthy state, and so on. All this goes into resource customizations in the config map of the Argo CD. So these two are the changes that we need to do in order for us, one, to install a custom CLI tool in the Argo CD, two, in order for our custom controller if we have some specific statuses that Argo CD should understand and show it in the UI, we need to configure using the resource.customizations. Now let's look at how this controller is working underneath in the AWS accounts, right? So first we will have to create an AWS source account, and we have to create a Kubernetes cluster. This can be a GitOps-based cluster or EKS cluster, whichever we choose to create. And we need to deploy this controller into that. And we need to create an IAM role. This IAM role will have to have permissions to assume a CloudFormation master role in a target account. There can be multiple target accounts, so we need to create this in every target account where we want to create the AWS cloud resources. And this will have permissions to create CloudFormation stacks and pass a CloudFormation service role into the stack. And this service role will have a power user access in the account so that it can create the change sets and execute the changes to create the resources in the AWS account. So this is how we create all the AWS cloud resources. We have seen that we have used this Mani as a CLI tool. In order for this to download content from S3 buckets, we can configure a role called Mani S3 role so that it can go and fetch the data from S3 bucket wherever we have configured it and replace the template in our CR declaration with the actual CloudFormation stack content. Yeah, so that is all the inner workings of this controller. Now, after we have this in place, we have seen tremendous results. However, I'll walk you through the state where we were in before this, right? So when we initially started creating clusters with the KOps-based approach, we were creating the clusters almost, a single cluster used to take 2 weeks. Although the KOps-based cluster creation as such for the core Kubernetes cluster creation, it was not taking much time, but creating all the AWS resources was taking time. And managing these AWS resources, like whenever we want to make changes to these resources across multiple clusters, it gets to be very difficult. And auditing and debugging of these clusters was a challenge as well, right? So whenever something that we update it, let's say we're using a script, we don't know whether that is landing up in a successful state or not. So we didn't have an easy way to audit who is making the change to them and control it and stuff like that. So whenever we try to upgrade clusters, we used to see the cluster upgrades used to fail because some of the resources were in bad state or they got deleted by mistake and stuff like that. So this was all a big problem for us in the earlier stages. When we decided to move from KOps to EKS based clusters, we had a migration to move from KOps to EKS based clusters, essentially to simplify the management of control plane. We introduced this GitOps-based management of AWS resources using this project called AWS GitOps. With that, we were able to create as many as 50 clusters per day. We are only limited by IP availability so that we don't consume all the capacity given to us. And all the EKS clusters that we plan to create, we were able to create all of them in 2 weeks. And we saved about 15,000 manual hours with this bulk cluster creation using AWS GitOps. Today, we are managing about 3,000 cloud resource custom resources across all the accounts and about 10,000 AWS cloud resources, which can be a VPC or a security group, NACLs, or private links and stuff like that across all the resources seamlessly. This is the impact that we had with this work that we did. Thank you.
Oh, sorry. And thank you, Ravi and Todd, for the great talk. And I guess Ravi is here and he's ready to like take questions. And but I guess we are really out of time. Thank you, Ravi, for a very insightful session.
Sure. Thank you so much for giving the opportunity. It was great.
Yeah. No, you have shared a lot, and I guess Ravi, folks, yesterday Ravi has shared. Ravi along with Nipendra did a Argo CD workshop, which was well received and most top workshops of all the workshops in the Kubernetes community Bengaluru. And I wish that we will see you again in person in a conference, Ravi, and again talk more about Argo CD, GitOps, etc. Thank you so much for joining. Great. So next up, we have another talk from securing workloads on enterprise Kubernetes deployment using service mesh. We all know like service meshes are like really popular, and then many people keep talking about different service meshes. Rahul and Sudipto are going to present at the talk today. Rahul is a software engineer at JP Morgan, and he works on the cloud platforms team, especially like towards the Kubernetes and the service mesh, and works in the cloud modernization journey of the bank. And Rahul has previously worked on other open source projects like OpenStack and Cisco, as well as HP Enterprise. Similarly, like Sudipto is also like working at JP Morgan as an architect, and then he also like worked in the service mesh and on the like K8s, etc. And he has experience working on multiple private cloud platforms. Like I guess when it comes to private cloud and everything, I guess the talk is definitely going to be very, very interesting. So let us quickly kind of like see their talk. Here you go. Talk playing in. Okay.
Everyone, my name is Shudipto Rai. Today, I, along with my friend colleague Rahul, going to talk to you about securing workload using service mesh. Security is an important construct for your application, irrespective of the organization that you belong to or the kind of role that you play for your organization. We will see how a service mesh can help you better the security posture for your application in a completely non-intrusive way. But to do that, let me quickly get through the agenda. We'll first of all introduce what a sidecar is. We'll also introduce what a control plane is and how these two things can help you with your modernization journey. How a sidecar can help you with encryption, authentication, authorization. At the end, we'll also look at one auth2 flow, wherein we'll give you an example wherein we have offloaded the complete auth2 out from an application onto a sidecar. Moving forward, let's look at a typical modernization journey, right? So we have a monolith application here. Let's say it's written in Python. However small or big the application is, it is trying to do three things. It is trying to connect, secure, and observe. With secure, what I mean is maybe it's implementing MTLS. And to do that, it is embedding the certificate into the application. With observe, maybe it is exposing some kind of APIs, and we need to know whether you're receiving 200 OK for all the APIs. Now, all of these things are done by embedding libraries into the application. Now, till the point this is one single monolith application, it's all good. But in your modernization journey, we have multiple teams coming in, and they are trying to break this particular monolith into smaller microservices. Let's say one other team has chosen to use Golang as the preferred language to break this monolith into smaller microservices and implement some other feature. But the moment it happens, what creeps in is feature parity. All the libraries that you're trying to embed into the application, they will never be same. You will always have a feature parity. And now that it's broken into multiple microservices, you don't know which microservice is going to have an expiry of cert next. And the moment that happens, you lose that particular microservice. So you're losing your control on your microservice or the application. This is not why you started your modernization journey. Why you started your modernization journey is to make sure that you only focus on the business logic. And all of these cross-cutting concerns that we talked about should be offloaded outside of the application. How can we achieve that? We can achieve that by using something called a sidecar pattern. A sidecar is a proxy which sits just next to your application, and it receives each and every connection that happens to and fro from the application. Because it is staying, or because it has such a strategic position, we can offload, connect, secure, and observe to this. And this is what makes service mesh, this is what gives service mesh the greatest advantage. It has also achieved a higher sense of separation between the business logic and all the cross-cutting concerns. But this is what you want. So this particular sidecar, it can be used for each and every language, and because it can be used for each and every language, what you get is integration cost. You integrate once and you're done. You don't need to integrate again. So using such a pattern, what you receive is you receive a lower integration cost, you receive a lower engineering cost, a lower maintenance cost, and all of this is happening in a completely non-intrusive way, which again brings down your time to market. This is the right time to introduce what a service mesh is. A service mesh is an abstraction layer that takes care of service-to-service communication, observability, and resiliency away from the developer onto a declarative configuration layer. A service mesh has two major components. One is called a proxy and one is called a control plane. Proxy is something that we already looked upon in the previous slide. It helps you with connect, secure, and observe. With connect, what I mean is L7 routing, load balancing, service discovery, rate limit, quota, circuit breaking. All of these are very, very important for any modern language, and all of these is something that you get for free the moment you take this particular sidecar pattern. It also helps you achieve authentication and authorization. It completely takes away the certificate lifecycle management. It's a very big plus. A sidecar also emits a lot of logs, a lot of events, and you can build a complete alerting solution on top of that. But again, sidecar in isolation can do nothing. It has to be programmed, and that is where the control plane kicks in. The control plane is the plane with which you as a user interact to, and you pass on your configuration. The control plane converts that configuration into something which the sidecar understands. The choice of control plane also determines the kind of control and policy enforcement that you can do with your microservices. So it is an important aspect whenever you think about implementing service mesh. Going forward, we are going to look into the security and the policy aspect in this particular presentation. And to do that, I will hand it over to Rahul. Over to you, Rahul. Thanks.
Hello, let's understand the security landscape in Istio. There are two tools, the X509 certificates and JOT tokens, and the actions can be broadly classified into encryption, authentication, and authorization. So encryption depends on X509 certificates. The authentication depends on both the certificate and the JOT token. And the identity that is built out of the authentication mechanism is used by the authorization mechanism in Istio to actually enforce fine-grained policies. So let's cover the tools. The JOT token first. So the JOT token is a kind of a signed token, which is broadly made up of three areas. So the first is header, the second is the payload, and the third is the verified signature. So if you change the payload, the signature cannot be verified. So that's the mechanism which JOT token uses to securely transfer the payload. The certificate is another mechanism which is used, the tool which is used. So this is how a certificate would look if you open it in a file. If you use the OpenSSL utility, it can be decoded and you can see the various components. The components which are of major interest are highlighted here: the issuer, the validity, the subject, the CN in particular, or the subject alternate name, the SAN name, which is embedded in the certificate as identity. So let's understand how certificates are generated. So most of the, a typical company has a team which is the root CA, which generates the root CA and maintains it. The application team generates a key pair. The public and the private key, and it generates a cert sign request, which is sent over to the root CA for attestation and signing. So the root CA first checks the identity which is embedded in the CSR, and if it can verify that the identity belongs to the person who says that he's the person, then it actually signs the certificate and sends it back in form of a digital certificate. So let's understand the first classification of operation of security in Istio, which is encryption. So for encryption, Istio uses X509 certificates. So I'm sure most of you are aware how certificates are used in encryption, but just a refresher. So the client sends a hello message, the server sends back the certificate, the client verifies the certificate, and then it generates a secret key, which it sends in being encrypted using this certificate. So that secret key can only be decoded by the private key, which is held by the server. Then it uses this certificate for continuing the rest of the communication. So the first part is the asymmetric key, which is used for the symmetric key exchange, and the rest of the traffic is secured by symmetric key, which is like much faster and hence. So what are the challenges with application certificates? So securing the private key for the workloads, the certificate is a public identity of a workload. So, and it can be shared publicly, but the private key is actually the secret that needs to be maintained. So how do we encrypt the key when we are sending it into the workload, or how do we store the key when it is at rest? So this is like a big challenge. How do we ensure the certificate are renewed before they expire? How do we attest and say, the workload which is requesting the certificate is really the workload which has requested it, and it's not somebody who's trying to become somebody else and do mean things. So attesting workload certificate is very important, and also it becomes specifically important in while we transition to the container ecosystem, right? So how do we create the certificate first, or how do we attest a container? So the traditional systems have used HTTP challenge or DNS challenge, so that changes a bit in the container ecosystem, and we'll discuss about it in later slides, and how Istio actually solves this problem. So how do we revoke workload certificates? Do we fall back on short-lived certificates, or implement a protocol like OCSP or CRL? So, and how do we ensure that where our certificate should be trusted? What is the trust boundary? If there are like multiple clusters, should it be trusted across clusters? If it has to be done, what would be the trust bundle exchange mechanism? So for most of these challenges, Istio relies on something called a SPIFFE standard. That is like a complete topic in its own. We'll try to cover as much as possible. So at first we define how certificate is provisioned in Istio. So when your application comes up on any Kubernetes cluster, a kube cluster actually injects a token corresponding to the service account which is there in the pod. So if you have defined a service account, it explicitly gets that service account, or otherwise it picks up this service account which is there for the default. It picks up the default service account which is there in the namespace. So the token gets injected based on the service account, and when the application comes up, the pilot agent takes this token and sends it and creates a CSR key pair, a CSR, and it sends it along with the service account token. Now the Istio CA, when it receives this request, it forwards it to the kube cluster to check the validity of this token against the token review API, and then it validates that the workload which is requesting it is really the workload which it says it is. So post this attestation, this STOCA returns back a signed certificate, and then the pilot agent pushes the key and the certificate via an Envoy SDS mechanism. This not only ensures the secure delivery, but also ensures that the certificates are hot reloaded and you don't have to restart your application pod every time you are renewing certificates. Also, one key thing which you have to notice over here is that your key pair, the private key, is never leaving the pod. So an enhanced form of security as well, right? So let's understand how authentication is achieved. If you look at the authentication based on certificate, we have a decoded istio workload certificate. So the key things that we would want to see over here is the validity, which is by default 24 hours, but it can be made even shorter. So istio relies on short-lived certificates and does not rely on any revocation list or OCSP. In comparison to a traditional certificate, the CN field is empty. Rather, the identity of the workload is embedded into the SAN, and it is in SPIFFE format. So, which consists of the cluster identity as well as the namespace and service account identity. It's the SVID, the SPIFFE ID, is actually a summation of both of this. So in a mutual TLS scenario, your server and client both have to retrieve the certificate. The certificate contains the vetted identity, which is embedded in the certificate for the given workload, and it is easy to enforce MTLS across the mesh with use of Istio CRDs. So there is a CRD called peer authentication, which defines what kind of traffic will be accepted. So you can and then there is a destination rule CRD, which actually governs what kind of traffic will leave your workload. So the kind of TLS modes that can be enforced when the traffic is sent is simple, mutual, or istio mutual, or disabled. So difference between mutual TLS and istio mutual is that the certificate in istio mutual is signed by istio CA, and in mutual it could be any external CA. So the policies to accept traffic could be strict, permissive, or disabled. So in a permissive mode, it accepts both encrypted and plain text, and it is primarily used for migration scenario where some of your workloads have been migrated to MTLS, but you're still in process, and some of them might be migrated a little later. So let's also understand the authentication which is achieved via JOT. So typically your client application, it requests for a JOT, and the authentication server mints it and responds with a JOT which is signed using the private key. So your client application sends the JOT token along with its request in the header. The service then fetches the public key and verifies the JOT token. And once it is verified, it extracts the payload, and whatever is there in the payload can be through the validation, it ensures that the payload has not been tampered with. So request authentication CRD in Istio helps to extract this metadata, but it needs to be used in conjunction with authorization policy to make real sense. So it just extracts the data, but you can only allow or deny traffic, or you can apply policy using authorization policy. So whenever you're using request authentication, you need to use authorization policy along with it. So let's look at authorization in a little more detail. So if you have like services, the front end service is talking to the back end service. You have the JWT authentication filter and a cert based peer authentication filter, which kind of perform the authent functionality, and they extract the payload claims and out of the JOT token and SA service account token and the namespace info out of the certificate. So this is stored in the filter metadata, and this filter metadata is used by the fine grained authorization policy, and you can build fine grained rules around who can access what or when. And let's see an example. So this is an example of a JOT, extracting issuer out of the JOT token, and then using this an authorization policy to ensure that you have requests coming out of couple of issuers, defined issuers actually. You can use cert and JOT in conjunction. So typically JOT is used in the north-south scenario, and the MTLS used in east-west scenario, but JOT can also be used in an east-west scenario. But this policy clearly lays out how you can have identities which have come out of the certificate, and then there are identities which have come out of the JOT token, and you can build an authorization policy to kind of allow, deny traffic which is coming from a source, or if it follows a given condition.
Thank you, Rahul. Next, we are going to look into an example pattern to see how we have been able to protect an application without making a single line of code change to it. But to understand that, we need to understand what a bearer token is. A bearer token is nothing but a JWT token. A user receives it at the end of the OAuth 2 workflow when it has successfully authorized or authenticated itself against the authorization server. This particular bearer token is always passed to the protected endpoint. The protected endpoint receives this particular bearer token, it cracks it open to look at something called claims. Claims is a part of the payload here. If the claims are right, then the user is allowed access to the protected endpoint. If the claims are not right, user is not allowed access. Now, these claims can differ. These claims can differ if the protected endpoint can somehow let the authorization server know that it should mint the bearer token only to be used at this particular protected endpoint and nowhere else. It does it by adding an extra parameter called resource, as you can see in the right. With the extra information that you receive as a part of claim, you can write much finer policies. Let's understand this with an example here. Let's say you have an application, a legacy application called HR World. This is a utility application and there are still users of this. And this particular application should be used only by employees who have HR roles, and all the non-HR folks should not be able to use this particular application. But how can you even achieve that? A sidecar pattern can help here. Envoy proxy being the choice of the sidecar here. You can program Envoy proxy in such a way that when a user is trying to access the application, the Envoy can look into the HTTP headers to see whether there are any bearer token available or not. If there are no bearer token available, it can initiate a OAuth 2 workflow for you. The moment OAuth 2 workflow is initiated, a user gets a JWT. The user passes the JWT back to Envoy. Now Envoy can verify whether the JWT is right. If the JWT is right, then it has capability to look into the claims. It can extract the claims and it can match whether the claim matches what is programmed, which is employee role equal to HR. And in case if it does, then it will allow access to the backend application. It is a very, very powerful pattern. And we have been able to move a lot of application using this pattern from an old platform to a new platform like Kubernetes. OAuth 2 already had this particular workflow, but then this is a recent contribution that I made to Envoy proxy. I added the capability to add the resource parameter, and when we did that, we started receiving final claims, and that actually unblocked all of these patterns. In JPMC, because of the sheer volume that we see these kind of use cases popping up each and every day. In case these kind of use cases is something that you look forward to or excites you, feel free to reach any one of us. With this, I'd like to thank you for listening to us patiently, and I would also like to thank Kubernetes Community Day for inviting us to their forum. Thank you.
Thank you, Rahul and Sudipto. I guess Rahul and Sudipto, you're already here. Thanks for one wonderful talk. Yeah, I mean, I guess like today we have like not so many questions on the chat, but then like there is Slack group. Please join the Slack. We are creating specific speaker threads, and yeah, I mean, thank you for an awesome talk on especially JWT and securing workloads. Yeah, cool.
Thank you. Thank you. It's been a pleasure. Thanks, everyone.
Thank you, Sudipto.
Thank you.
Okay. Next up, we have an interesting talk as well, that too on the eBPF. So the next talk is specifically on system state clustering with eBPF data. eBPF is a very famous project in the entire CLCF area. And like, you know, Cilium is a very popular project. So Sujit is a principal software engineer at AI platforms at Ericsson. He's exploring the relevant open source technologies to integrate with next gen their ML platform, and he's also very interested in observability, which is my interesting area as well. He's been working with high performance data science teams in the capacity as an engineering manager and as well as a technical architect with companies like Ford, Wipro, and Nissan. So quite an interesting bio, and I would definitely like appreciate, like, you know, the Sujit's talk on this niche technology. Here we go.
Good afternoon. Welcome to the presentation on system state clustering using eBPF data. My name is Sujit Samuel. I am a principal software engineer at Ericsson in the Global AI Accelerator unit. One of the responsibilities that I handle is the system state observability. We monitor the behavior of the systems to ensure consistency and security. What are we going to cover today? We're going to see what is eBPF, what is clustering, what is eBPF and clustering together, what are some of the potential use cases of this, and finally we can go through some questions if you have any. What is eBPF? eBPF stands for Extended Berkeley Packet Filter. Prior to this, there was BPF, which is the Berkeley Packet Filter, primarily used for analyzing network traffic in operating systems like Unix. eBPF programs are event driven and are run when the kernel or an application passes a certain hook point. What this allows us to do is to extend the behavior of the Linux kernel. Traditionally, if you have to extend or if you have to contribute in some way to the kernel so as to modify its behavior, you have to do a lot of testing. You have to ensure a lot of consistencies in the code. What eBPF allows you to do is write your own custom programs which are executed at certain points in the execution of the kernel, and those programs which you have written will be isolated and will be tested by something called an eBPF verifier, which ensures that your user space program or the eBPF program does not access anything more or violate the memory constraints that it is supposed to respect. When all can you execute eBPF programs? Predefined hooks include system calls, function entry exits, kernel trace points, user trace points, network events, and several others. Once you hit that entry point or wherever the eBPF program is attached, you can run that program and pass the data back to the user space via something called an eBPF or BPF map. What are these maps? These maps are, you can consider them as a cache which stands between Linux space and the user space. So the eBPF program will populate the BPF map, and your user space program can actually access that BPF map and do its own processing. So here we see the pictorial representation of whatever I was talking in the previous slide. So you can see eBPF can attach itself to some execution points in the kernel, which are called whenever, let us say on the left hand side, we see a storage driven eBPF call. Any process that reads or writes calls the eBPF program just by the virtue of the eBPF program being attached to a storage syscall. On the right hand side, we can see the same thing, but on a network event. So a traffic comes in or a request comes in. We have our XDP or the eBPF program, eBPF XDP program that is attached on that particular network request, and it triggers itself. So that program can actually pass in again the data back. So you can see it is attached to sockets, it attached to all these TCP/IP interfaces. So this is how eBPF allows us to customize the behavior. So you can, at any point, at any place in the Linux kernel where you can insert something or you want to monitor it, it is possible by the virtue of eBPF. This here is an example of an eBPF program. As I said, there are on the top we see a struct called a map, and down we see a section which is actually going to be triggered on a kprobe. Kprobe is a kernel probe, right? You can attach this particular eBPF program on the function xsysexecv, and this will tell you how many times that particular function has been invoked by the virtue of this particular eBPF program which executed in the kernel space, passing the value into a map that is being read in the user space. So here you see in the section, in the actual program section, it actually looks up the map and sees whether the element already exists. If it exists, then it increments the value. If it doesn't exist, then it will create the value and update it, right? So this will actually increment each time that particular function is called, and that incremented value sits in the map, and the map can be read in the user program. And that's how it works. Now we're going to see what is clustering. Clustering is a machine learning algorithm which can help us cluster different data points into multiple classes. This basically lands upon the premise that things which are similar tend to be closer to each other than dissimilar things. On the right hand side itself, you can see that this particular graph, right? We see that there are some black points, there are some red points, and there are some green points. And there is a very well-defined line or a demarcation between each of the three different points. Now this has been achieved by an algorithm called k-means, right? K-means, and if you say three clusters, right? So k-means is a machine learning algorithm which says that, okay, I will help you cluster your data points into whatever clusters that you decide, and based on that, this k-means will actually run some sort of algorithm behind and say that, okay, this cluster belongs to this point belongs to this cluster, and this cluster has the centroid of the cluster is this, and each cluster will have a centroid, and the distance from the centroid will actually be determining the class of that particular point, right? So clustering is essentially a machine learning algorithm that helps us to group similar behaving data points or similar data points together. So here, just to cover a clustering example, we know about the dataset, the iris dataset. The iris dataset is a very famous dataset in machine learning, and almost all the people who start machine learning actually definitely encounter this dataset in their starting time, right? When we use the dataset to do a lot of machine learning trials ourselves. So what this dataset contains is a list of a number of records with different details about a flower, the iris flower, right? The details are given like petal width, sepal length, petal length. All these details are given, and there are a lot of records which actually need to be segregated and clustered together to understand the closeness of the data points, right? Now, if you see this graph that has been projected, we clearly see that there are three different data points, right? So there is a green one, there is a yellow one, and there is a kind of a violet one that towards the end, towards the end side, right? So this is actually a very good example of a machine learning algorithm called clustering running on that particular data set and helping us to identify these three different clusters that you can see, right? I picked up this example from scikit-learn, a really great clustering algorithm called k-means. Now, how do these two terminologies that we discussed, these technologies that we discussed, right, eBPF and clustering, they can come together, right? eBPF can help us to generate data points, right? So what all data points do you want to generate? You can generate data point about access of a particular file. You can generate a data point about network requests that come in. You can generate data points about behavior of that particular system as in the CPU load, or is how many read failures, or these are the kind of things that eBPF can help us generate. And once that data is generated, clustering can help us cluster the data points, right? How will clustering help us to actually segregate the data points? There could be an innate sense of algorithmic understanding which says that which the clustering can provide us, saying that okay, this particular data point that has been generated might not be a good network access, right? You could actually help by doing some sort of data labeling. Create some sort of test scenarios in which you have negative classes and positive classes, and then data labeling can actually aid this particular machine learning process. So not essentially clustering, but some sort of labeling that can be used to provide some sort of input to supervised algorithms. Now clustering is an unsupervised algorithm, but you can use this data that is generated in eBPF to run some supervised machine learning scenarios. In production scenario, you can use the model, what all you have generated, to actually predict in real time whether the data point actually belongs to a right behavior of the system or wrong behavior of the system. So our aim here is basically to understand whether the system behavior right now is actually correct or it's not correct, right? And the idea that we are discussing here is whether eBPF can help us. So clustering can help us to understand or segregate the data, whether eBPF can help us to generate the data, whether the combination of this can help us understand whether the system is behaving in a proper way. That's what we are discussing. So I believe eBPF can generate the data, clustering can help us cluster the data. So just to elaborate on the scenario that we discussed in the previous slide, right? So there are some classes of eBPF programs, right, which are going to detect network, which are going to be attached to network interfaces. So this is an XDP program. There is an eBPF socket filter program. So XDP basically stands for Express Data Path. So Express Data Path basically means that this is an interface that is going to be hit the first whenever a network packet is received, right? So by that, what I mean is, at this point in time, even a struct socket buffer has not been allocated. The SKB struct has not been allocated, and it has not been passed through the network stack. So it has first hit the XDP buffer is allocated. What all you can do at this particular point of time is you can actually analyze and you can reject that particular packet at a very early point in time of the network request, so that there is not enough load on the system to actually allocate all these buffers, right? And that will help us alleviate some of the system load in case we understand that this is from a wrong IP, or this is a network attack, right? So what happens is, whenever a network packet is received and you have an eBPF program attached to an express data path, right? This particular program will actually read that particular packet and will actually extract some details from there, right? Like input, what is the IP address that it's coming from, what are the headers, what are the header informations, what number of bytes, whatever it is. You can take any details from it, and then you can put into this particular thing called a map that we already discussed. Now this map sits in between of the kernel space execution as well as the user space, right? So all the details that you have put into the map are actually accessible on the user space now. So once the kernel or the eBPF program has actually put into a map, you have a user space program that actually reads the map and, let's say, pushes this data to a really fast cache store, like to a really fast store like Redis, let's say, right? What happens once, so this data is continuously going to Redis, right? And then your machine learning platform could actually read this particular data and run clustering on it, right? Run clustering on it to understand whether this particular network request that is received is actually good, or is it a valid network request, or is it really because we all have some predicted or predictable behaviors, right? Anytime any behavior mostly is predictable, right? So there are time series algorithms which could run on this particular data to understand whether this particular behavior of network or network packet request is really something that we expect. If not, then yes, we have aided the system observability by actually classifying a particular network behavior as invalid, and that is possible because we have used this eBPF and clustering together. So eBPF can help us to understand the real system behavior. Clustering will run on the data that is being generated by the eBPF to actually help us to understand whether this behavior is expected or not. So here we see the network traffic use case in a little bit more detail, right? So on the left hand side, you can see, so there is a receive queue and there is a transmission queue, and right, and then there is this BPF program that is actually sitting on the driver on the interface, right? And this program can actually do three things. It can pass the traffic up the network stack, it can actually redirect it, or it can just simply drop it. Drop basically means that that packet will never travels up the stack, never loads your system, and that's the best place to actually reject the incoming network traffic. Now, a lot of DDO, distributed denial of service attacks, actually can be dropped if the XDP program is really good enough, right? So what happens on the left hand side, you see an incoming request, right? The incoming request reaches the receive queue, and at that particular point of time, it is actually intercepted by the XDP BPF program, right? XDP BPF program actually intercepts the request, and then this particular BPF program actually can write this data, whatever data you want, along with the time of the request and everything, into a map. And then the user space program actually reads the map and sends the data to a clustering system to ascertain whether it belongs to a valid cluster. The valid cluster, we saw what is a valid cluster, right? We saw in the iris example, right? There are clusters of, let us say, there are clusters of data points which appear valid. There are clusters of data points which appear not valid, and there are clusters of data which can downrightly be rejected. So if we find out that the data that is coming, which is being populated in the map, actually belongs to a downright rejected traffic, then yes, this methodology can actually help us to reject the traffic right away and help us improve the performance of the system in case of things like attacks like DDoS attacks or any other attacks that we see. So here we see it's a really good combination of a functionality that is being used to extend the Linux kernel and machine learning. Both these things can work together to actually aid in better performance of the system. This is one more use case which is tied to the observability of the system, whether you want to see whether the system is behaving properly or not. Basically means that when your system is executing, should a particular program be triggered, or should a particular file be accessed or not, or whether if it's getting accessed, is it getting accessed correctly or not. So for those kind of things, we can actually attach eBPF programs to events, right? Perf events, right? You can create perf events. Those particular events are attached to kernel functions. So you have a kernel function that is triggered. The kernel function which is triggered actually has the eBPF program attached to it. Once the eBPF program gets triggered, again, it populates a map. We know the map. That map is being accessed from user space program. The user space program actually takes the details from the map and sends it over to the clustering algorithm. The clustering algorithm then determines whether that particular file or the executable that is accessed is supposed to be accessed in that way or not, or supposed to be accessed at that particular time or not. And then it says, yeah, it's a valid access, it's a non-valid access. So again, this is one of the use cases in which you again use machine learning to actually understand whether the system that is being observed has correct behavior or not. So we saw in the previous slide the network traffic check, right? So an example in this along the similar lines could be system performance degradation check. So what is a system performance? System performance is nothing but how you expect your system to actually perform during any point of time, right? When it is getting degraded, when you have a lot of read failures, let's say you have a lot of read failures, or you have a lot of packet drops, or you have a lot of indicators that are being generated to say that okay, my system is not behaving properly. Those kind of things are definitely can be found out in the kernel itself. So kernel, when it is trying to give out some indicators like system performance is getting degraded, at those points of time, eBPF program can help us to actually take that data move it into a central map, and then user space programs like to read those maps and say, okay, yeah, system performance might get degraded at some point of time in the future. So that's a time series analysis that we can do. You can actually have machine learning algorithm which can actually read the data of the system performance degradation data that is being generated by the kernel and actually help us to predict, okay, you know what, I have seen this trend earlier, and this basically means that in another 10 or 15 minutes you are going to have a systems down notification coming up, so please take care of that. That again leads to a use case like preventive maintenance, right? Why do you need to maintain things like hard disk racks or storage racks? So you have disk failures that are starting. So disk failures, when they begin to happen, you have many other ways to check whether disk failures happen. But this is again some of the use cases, that potential use cases that we see. If we are if the internal PMU counters or management unit counters actually help us to understand some sort of system load, then that again can be fed into an eBPF map, and eBPF and the algorithm on the other side can help us to understand whether this particular data point that has come in is actually a positive data point or a negative data point. Yeah, that's a good thing. So that's a good thing that can help us to really make use of these two technologies together. So yeah, so these are some of the use cases that we see, and actually we are trying to explore all these use cases right now, and try to see how eBPF and clustering can come together. And with that, we come to the end of the presentation, right? And so we have seen how eBPF and clustering can help us in actually predicting some sort of system behavior in the future. It could actually help us to do much better with the system observability use cases that we are currently pursuing. And we are actually currently working on a lot of such use cases, yeah, right? And the implementation is right now in progress, wherein some sort of machine learning and eBPF can come together, and whether it can really help us to predict a system down much in advance as compared to the existing methodologies, or as compared to the existing technologies that we have right now. So with this, we come to the end of the presentation. I would be more than happy to take any questions if you have. So yeah, thank you.
Thank you, Sujit. I guess we have Shudit in the stream as well. So thank you for that great talk. And I'm really excited about eBPF in general, because I've been watching over for quite some time about eBPF, Cilium, and various other community folks who are talking about it. That's a great talk. And I guess because in the interest of time, maybe we don't have any questions or something like that. But then, but yeah, thank you for giving an interesting talk.
Yeah, I would like to thank you for the opportunity, and you guys are doing great in furthering the cause of the community. So all the best.
Thank you, Sujit. And please head over to the Slack to talk to Sujit, or the networking table, or anywhere. He'll be there answering all your questions. And again, once again, thank you, Sujit. So, okay, that's a very interesting talk from eBPF, to be really honest, and he explained everything so detailed. So the next we have similarly a great talk on something that is very favorite, or like every SRE wants to happen, that same thing. We have a talk from zero time security, zero downtime deployment on Kubernetes, which obviously is a fantastic topic to discuss. And for that, we have today Nick. I'm sorry if I'm not pronouncing your name right. Nicholas Frankel, developer advocate with 15 years of experience for consulting various customers in a wide range of contexts. And he usually works on Java, EE, Spring technologies, focused on interests like rich internet applications, okay, JSF maybe, and CI/CD, DevOps, and all. Nick is also here to take questions, so feel free to ask questions. So and here we go, and let us listen to his talk now.
Hi folks, thanks to be here for this talk about zero downtime deployment on Kubernetes with Hazelcast. I am Nicola Frankel. I've been a developer for a long time, or an architect, or a team lead, whatever have you, while on technical roles, and since a couple of years, I'm a developer advocate. I'm by far a Kubernetes expert, but we live in interesting times. There are a lot of things to learn, and Kubernetes is among them for me. I work for a company called Hazelcast. Hazelcast has two products. The first one is an in-memory data grid, and you can think about an in-memory data grid as distributed data structures. So you can shard your data, you can replicate your data across nodes in the cluster. The other one is Hazelcast Jet, and it's an in-memory stream processing platform. And I won't talk about it further because I will use them in my demo. So the first question is, why shall we do zero downtime? Well, the first reason is because business wants it. If you are an e-commerce shop, and I know this is a pretty popular example, or overused, well, you want to sell. You want to sell all the time. So downtime means, first, you don't sell, and during this time, your customers might buy to another shop. They will probably wait not that much time. They will probably decide, hey, this shop is closed. I will go to another shop. So it has a direct impact on the business. And the second reason is a side effect, is because like the big companies out there, the Google, the Facebook, the Amazon, Apple, like the big ones, they are always up. Their applications are always up. So that users who don't know about IT, they start to expect that applications are always up. So if Google's applications are always up, why yours are not? I mean, they don't understand the difference. People who work in IT, we have been working in IT for a couple of years, and yeah, we know how to deploy with downtime. We go to the proxy, we set a static page, we're saying, hey, please come back. But the big ones, they deploy all the time. They don't do like that. And so people get used to that. And if you cannot compete with the big ones, then probably you will have a problem of image, saying, hey, why are you doing that? And if we are talking about zero downtime, I'm sure you are pretty familiar with the blue-green deployment model. So the idea between the blue-green deployment model is you've got your production environment, and let's call it blue. And meanwhile, you have a similar environment, let's call it green. But for the moment, the users, they are directed to this blue environment. So at the moment, this environment runs the version 1 of the application. And at some point, business or in an automated fashion decide, hey, let's deploy something on the green environment, the V2, and when it's ready, the users, they can be directed to it. And the next step, of course, is let's deploy the V3 on the blue environment, and again, let's switch between the blue and green all the time. So the prerequisite is we must have those like two similar environments. There is an alternative to that. Here we have like one single database or like one database per each environment. And I will come back to it later because it's pretty significant. It has a huge impact. And it's a real problem when we do blue-green environment because everything is related, every issue is related to states. And it's not only about blue-green, it's about when you want to do zero downtime, you need to have like to handle state. And state is found in two places, like in the application themselves, on the application nodes, probably user sessions. Even if we don't want to use user sessions, in general, we use them because it's not feasible every time to go to the database or to the dev server or to any data store. So when the user logs in, for example, you're probably happy to store his first name and last name in the session and then display it in every screen. And of course, there is state in the database. And Kubernetes came and proposed something very interesting, the rolling update principle. So it's like different from blue-green. we have a single environment, we have different pods, and we will like upgrade each each pod in turn, and you can configure how long it can take, you wait until it's ready, whatever, but this is the basic principle. And again, still, it doesn't solve the step-related issues. It doesn't solve the sessions problem, it doesn't solve the database problem. On the session problem, I believe it's a solved problem. Like, we have session replication. We have been doing session replication since ages, just because if we store states on a specific pod and the pod goes down for whatever reason, even if we don't want to deploy something, well, we need to keep the session data. So we have been doing session replication since ages. I won't go in detail over that. Just in the demo, it just works, and you can check the documentation. But the real issue is on the database side. And we have actually two options that I mentioned. We can keep the same database, and that's the way I used before, and I became like aware of some problems. And so let's go over this option, and then we will see how we can have two different databases, and like that's a much better choice. So first option, keep the same database. It seems like it's the best idea. However, there is one requirement, is that the application needs to cope with two versions of the schema. Why is that? Well, here we have 3 pods, and we have one single database pod. And let's do a rolling upgrade with Kubernetes. So if we just do a rolling upgrade, first we start with the first pod, and then we go to the database. And of course, the old 1.0 pods, they cannot cope with the 2.0 version, because there is no way they could have like inferred the future, and it breaks. So the idea is, it doesn't work like that. The idea is that the 2.0 version pods needs to work with a 1.0 schema. And it's completely possible. So let's do that. While we do the 2.0 version, when we develop the 2.0 version, we say, okay, if we have this schema version, we do this. Otherwise, we do that. It's okay. It's a bit more work, but it works. So we just like do the rolling upgrades on each pod in turn. When they are all ready, then we can migrate the database version. And everybody is happy, unless we need to roll back, because yes, we are all very good engineers, but sometimes for whatever reason, we need to roll back. And in that case, we cannot roll back, because as soon as we try to roll back, well, it's the same problem as before again. We have this 1.0 version that cannot handle the 2.0 schema. How can we do that? Well, let's have a very concrete example. Again, I've been working in e-commerce, so I'm using that e-commerce example a lot. We have this like stupid schema. Customer has multiple cart lines, and every cart line has one product. This, I started as an architect, I started with this schema. My application became very popular, and now the business comes, and the business has requirements as always. And now what they want is they want to keep a track when a cart was created. And then after some time has passed, there will be a job that checks every time and say, it has like 24 hours. The person has kept their cart, so they actually like didn't order, but we still have the cart, and we can send them a reminder and tell them, hey, we have this discount for you. You forgot perhaps to check out your card. Hey, here are 20% of discounts, please buy. I mean, this is a pretty normal for business. And so we need to redesign our application. And for that, we introduce now a new card table with a dedicated last modified attribute that will keep the timestamp when the card was last updated. Okay, how can we handle that like from the application point of view? Well, as I mentioned, it's a breaking change. So there is no way that your application can cope with this breaking change. So we need to handle the forwards and the backwards migration. So the forward migration and the backward rollback. So the idea is that we would need to split the breaking change into a series of changes that are compatible side by side, so we can always do a rollback if necessary. So how can we handle it for our e-commerce use case? The first step would be, hey, let's create the real cards table, and the app still uses the old data model. And now, every time we do a change on the cart line, when we add a cart line, for example, we will first check if like a cart line exists for this customer. If it doesn't, we will create this cart and we will attach it to the customer. And this way, if for whatever reason we need to roll back, well, that's not an issue. The database schema will have this cart table that the app doesn't use anyway. And when I say trigger, it can be like a real trigger because your database software can handle trigger. It can be through the code. It can be through anything. I'm not prescriptive in that. The idea is just, hey, like when a cart line is inserted, we check if the first cart line for this customer, if it is, then we create a new cart in the cart table. Okay, the second step is now the cart table becomes a source of truth. So the application uses the cart table, and again, there is a trigger that updates the cart line with the customer ID every time it inserted. Now, if we need to roll back, the cart line table will still be used, but it has the customer ID, so it's fine. The third step is we will migrate the in-touch data, and that's where the problem lies. And the fourth will be we will be doing cleanup, so we will remove the additional customer ID column in the cart line table. So why is the migration of untouched data a problem? Well, if you've got a couple of lines, that's fine. Because when we are doing this like migration, we infer that people are still using our shop. But perhaps there are people who had like cards who were not touched, and those needs to be migrated to the new schema as well. And the real issue is it can be a lot of data. It can be a really, really big lot of data. So it's going to take some time. And during this time, that means that we need somehow to have like the application still working meanwhile. So it's this third step is where the real issue lies. And it's not only that, of course, it will require you to like decompose this change into steps. Might not be that easy every time, so that you can roll back. And after that, so you have this breaking change, you will like split it into non-breaking changes compatible side by side. but you can still only roll back one single baby step. You cannot roll back the whole breaking change. So you can just only roll back one step. It will need to be planned across the whole organization. It impacts developers, it impacts like database administrator, it impacts the ops, and probably it will impact the manager who will need to plan. So it's a lot of organizational like effort. And as I mentioned, you will need to migrate data anyway. If it's a couple of lines, that's fine. If it's a lot of lines, yeah, not so fine, it might take too much time. And this decomposition of step is fine. It can be planned if you have like a small organization that only does it once. But imagine that you need to do those changes and they need to be deployed in parallel. It might not be possible at all. So the second option is, hey, we will need to migrate data anyway, so at least we need to embrace it. So instead of having a single shared database, we have the blue database and the green database. So how do we handle the migration? And that the real game changer here is we won't use jobs. We won't like start a bad job and end it. We will do streaming, meaning that we will get the changes as soon as they come, and as soon as they come, we will replicate those changes into the new schema. And you might have heard change data capture before, and that's how we capture the change from the database side. The problem of the database side, it's not an even source. So change data capture, we will change that SQL database to an even source that we can stream. And the benefit is that the developers, they are not impacted at all. It's completely parallel to how they work. And it's not actually like related to blue-green deployment. It can work with any deployment option you can choose, like for canary release. So change data capture, as I mentioned, is the way that we can like make a normal SQL database into an even source. So every change is tracked, every insert, every delete, and every update. So here we have like our starting architecture. And the starting architecture is actually, we have 3 pods of the same deployment. So pod v1, pod v1, pod v1, and they are using the blue database. The next step is we will set up the green database. So it's just the setup, nothing happens. It's just, hey, let's create the schema and the constraints and whatever. Now, the third step is we will create a data streaming job that will read through data capture from the blue database, and it will forward the changes to the green database. So every time there is a change in the blue database, it's replicated in the green database. And because of like the data streaming world, we can do some transformation because just replicating would be very, very easy. But here we are doing transform, so we adapt the changes from the old schema to the new schema. Of course, now we can start to do the rolling update, and at some point, one of our V1 pod will become a V2 pod that is configured to use the green database, and it has all the data it needs. After some time, all the nodes will have migrated to this like green database so that the forward job doesn't need to do anything because, well, there are no more changes. And the difference with the previous like approach with one single database and you need to migrate untouched data is that the forward job, it migrates data that has been changed in the past. So it's able to read stuff that happened before it was started. And so that is actually the definition of untouched data, but the rights are still there. Here I was too lazy to do it, but you can think about you need to design a backward job that do the exact opposite in case you need to roll back. And if you don't need to, then of course afterwards you are happy to do some cleanup, you remove the job and you might keep the blue database for a bit more just to be sure, and then afterwards you do the cleanup. So everything is fine. And how can we implement it? Again, as I mentioned, for session duplication is a solved problem. You can use Hazelcast for that. In-memory data grid, it's perfect. It's a perfect use case. In the demo, I will be using Spring Sessions because Hazelcast is a Spring Session implementation. For the database migration, I will be using Hazelcast Jets for change data capture with the help of Debezium. And as I mentioned, Hazelcast MDG allows you to store your data in memory so that session replication becomes a non-issue. On the other side, we have Hazelcast Jet, and Hazelcast Jet is a stream processing engine. It can read from different sources and writes to different targets. And meanwhile, it's distributed and you can do transformation, enrichment, whatever you want. So here in that case, this is my design. I have like this jet cluster and I have the blue databases. I will create my job and it will use the Hazelcast Jet jar, which uses intern Debezium.jar, which will in turn use Debezium MySQL.jar because Debezium is actually an abstraction layer that you can use to read from different databases. Postgres, here I'm using SQL, but so that in the end I could use like nearly the same codes to do it with Postgres. So I could even have like a MySQL blue database and a Postgres green database. That's not an issue. I believe I've talked a lot and now it's time for some demo. So here I have everything in IntelliJ, and at the end of the talk, I will give you a slide with all references that you can check. And this is in a GitHub repository, so you can use it out of the box. I've created an application, and this application is a Spring Boot application, but I don't want to go into too much detail. It's just a Spring Boot application with a POM. And how does it work? Well, it works like the following. I have deployed already everything like the blue version on Kubernetes. So I'm using Kind. I have been beaten in the past by Minikube, so I hope this demo works today. The first thing is I will need to log in. So I don't want to implement Spring security. I just want to keep it simple. So how do you log in into this application? And very important, you cannot do anything. You cannot check your cards. You cannot browse the catalog unless you have logged in. So how do I log in? I log in by like choosing a user here. So here I have user Joe, and now I am like authentified, logged in as Joe, and I can browse the catalog and I can put stuff in my cart. So here you can see in the right hand corner, I have like displayed just to like show you how you can, like how it works. And now I log in as Jack, and Jack has nothing in his cart. So I will add like one t-shirt, and perhaps I will add like William. I will add like 2 hoodies for William, and I will add Avril. I will add 3 stickers. This is just to show you how we will migrate the data. So I need some data to start with. Let's get back to Joe and add like a couple of marks. Here, this is our initial state. So if we go and check on Kubernetes, I have aliased the kubectl to k because it's much more comfortable, and I can check the pods here. And normally I should have 4 pods. It takes a bit of time. I have the blue database, so I have a deployment of 1 pod, 1 replica for the database, and I have a deployment of 3 pods for the application. The first step is actually to deploy, as I mentioned, the green database, the green environment. So I will apply infrastructure kube green. So this is just the database, the new environment. So get pods W. Normally it should be already up. It's very, very quick. So yes, it's already running, and we can check the logs. Okay, logs green-f. So MySQL is starting, and we should wait a bit until it tells me that everything is fine. Shutting down MySQLD is good. It's ready. It starts very, very quickly. So now we have a new MySQL instance. We are very happy. The next step is to actually deploy the forward job. So let's deploy the forward job. K apply F infrastructure kube forward. K get pods W. So it's already started, and K logs forward F. That's very interesting, actually. You can see that it already has started to replicate data to the green database, like from data that was there before it started. So now on the green database, you already have the exact same state as on the blue one, even though we just started the forward job. And if I just like go back to the shop and I add 1 more mark, we can see that instantly the forward job caught this change and updated the quantity on the green environment. So now every time we do a change, it's captured, transformed, and forwarded to the green environment. So the next step is obviously to do the rolling upgrades, which is the least problematic stuff. So K apply F infrastructure kube and application 2.yaml. And here K get pods W. We can start to, well, we can continue shopping. And the idea is that at some point, magically, I will be on a v2.0 pod. So here it's a REST call. So I will need to refresh. It won't be visible into the right upper right corner. Might take a bit of time. So sometimes my code, well, not sometimes, my front-end skills are pretty bad. So it might like squeal a bit, and I will need to refresh the page, but it's only because I don't know how to write really correct JavaScript. So it's still doing its job. And it's taking some time, of course. No, I thought it was. So meanwhile, I'm keeping an eye on the terminal, and normally at some point, this like pod should get killed and replaced by a new pod. Let's see if it has been killed. So, hey, I am already on the 2.0 version. And it was like, you saw nothing. And of course, I can continue now adding new stuff. So how does it work? Well, there is nothing magical, actually. The application is not that interesting. The forward job is a bit more interesting. We can see the source, and we can see that it's a plain normal Java application. Like, it has no dependency on Spring at all. It's completely like agnostic to the tech stack of the application. It's independent. It's just like a plain main like application. So here you start it with main. And here we can see a view of the pipeline. And I won't delve into the detail of what the pipeline is. Basically, the pipeline is the code that you send to the Jet cluster to get executed as a job. And here we can see that it reads from the blue environment, and it maps the record, because here we are using records, and we don't need to have this class itself. We just transform it to a map, and we map it further afterwards to call parameters, because when we write to the green environment, what happened is what we are doing is actually we are calling this like function called insert cart line. And what this function does is just a call to a start procedure. So whatever like technology you are using, you can do like JDBC, you can do GPA, you can do Hibernate, you can do whatever you want. In all cases, it will work. Like, it's just like plain simple Java code. Yeah, you can see it here, insert cart line, and it's a callable statement. Well, I believe I'm at the end of the time that is allotted. So takeaways for you. I believe that zero downtime is within everybody's reach, which was not the case before. I believe before I told people, hey, perhaps it looks like really, really hard. But with this approach, anybody can do it. On one side, for like data that is on the application pods, session replication, solve problem, just configuration and works. And on the database side, you have change data capture and data streaming. And it works like a dream. Thanks for your attention. You can read my blog. You can follow me on Twitter. As I mentioned, you can check the Git repository. Everything is on Git, so you can do that at home. And if I got you interested in Hazelcast, you are welcome to join our Slack. Thanks again, and have a good day.
Thank you, Nick, for a great talk again. I guess it's amazing. And folks, if you have questions to Nick, please feel free to like kind of drop him a message on the Slack, and he's there on Slack. He's there on the Baby. I just messaged him on the Baby as well on the conference platform. So Nick again, thank you for joining all the way from other continent. And yeah, we look forward to host you again and meet you probably in person.
Yeah, that will be my dream. Actually, before the pandemics, I was supposed to fly to India for the first time, and I was super happy. And well, you all know what happened. So until it gets back to normal again, I will be happy to like get online with you. And after all that stuff has finished, I will be very happy to meet you all in person.
Sure, sure. Thank you, Nick. Thank you. Thanks for the awesome talk once again.
Thanks.
Okay. After that awesome talk, we are gonna have. I guess we are running a bit late, but then we are really good on the timing. So we are gonna talk about debugging Kubernetes again, and Kubernetes node without Docker. You should definitely hear this talk because it's from Aditi and Naveed from VMware. And Aditi is a senior member technical staff at VMware, and she has a lot of experience contributing to both Kubernetes and OpenStack community. And then we have Naveed, who is also like a contributor to Knative. So if you have any questions to Knative, please also line them up, not just specifically this one. Okay, and without any delay, just want to play the talk. Go ahead.
Welcome to the talk. I'm Aditi. I work at VMware on TKG platform. Today, me and Naveed will share you how you can debug Kubernetes node without using Docker. So first question that comes to our mind is why we need this. So in Kubernetes 1.2 release, it was announced that it is going to deprecate Docker shim. To understand what Docker shim is and how the deprecation can affect you, we need to understand how Kubernetes communicates with container runtimes. To communicate with container runtimes, Kubernetes uses a gRPC interface called as Container Runtime Interface. Docker shim is the CRI implementation for Docker, which is maintained by Kubernetes community. Kubernetes only deprecated use of Docker as a container runtime. Docker images and Docker build tool will work same as before, as they follows OCI image spec. Let's see the reasons behind these deprecations. If we use Docker shim as a container runtime, the request from a kubelet to container runtime goes through many levels, and it can have some performance implications. The second reason is Docker is a complete set of tools that provides lots of functionalities like building images, networking, storage that Kubernetes does not need. The third reason is maintenance burden of Docker shim. But we are quite familiar to use Docker CLI to troubleshoot Kubernetes container, images issue, node issues. Like we are quite used to use like commands like Docker images, Docker inspect, Docker execs. So let's see what other alternatives are available if we do not have Docker on our node. So there are some tools to help you. The first one is CRI CTL. It talks to the CRI implementations of the runtime. The second one is Nerd CTL. It is a Docker-like CLI for containerd. The third one is CTR. It is a de facto CLI that comes with containerd. Now let's explore CRI CTL. So using the CRI CTL info, you can get various information about the node. Status of the node, network status, CNI config, what CNI plugins it is using, information about low-level container runtimes like runc, CNI status, etc. You can also inspect a container. So this is the container I have created a few hours ago. Let's inspect this. You can get a lot of information by inspecting a container. Like its status, the image it is using, logs of the container, commands that are running in the container, container capabilities. If you are running into some cap issues, mount information, and like it will go on. Okay. So it gives you a lot of information about your container. Okay. C group path, what namespaces the container is in. You can also run, you can also use debug option with CRI/CTL that prints the whole API response from the container runtime. Let's see this. Sorry, it is --t. Okay, so you can see it will tell you what complete container response you are getting from container runtime, and you can figure it out if something is missing or you are facing some issues. Okay, you can also use CRI/CTL to create containers, pods. Sometimes it happens that you are facing some issues that you are not able to figure out. It is from kubelet, or it is from container runtime, or it is from somewhere else. So to debug that, you can directly create containers or pods with container runtimes without involving kubelet. So to create containers and pods with CRI/CTL, you need to create some JSON files. Okay. So for pod, I have created this JSON file. I will use the runp command to create a pod. Yep. So let's see the pod status. Now we can create containers in the pod. So to create containers, you also need to create a JSON file. You need to give the pod ID first. Then the container JSON file, then the pod JSON file. We need to start the container also. So the container is running. You can explore lots of other commands with CRI/CTL using the help option. So this is all about CRI/CTL. Now there is one more tool called as nerdctl. Now Naveed will walk through you how you can use nerdctl. Thank you.
nerdctl command line interface has same US as of Docker, so users can use nerdctl and Docker interchangeably. As you can see on the screen, these are the different command groups being provided by nerdctl. There is container, network, volume, namespace, system, and image command groups, and all the functionalities under those command groups. These are the same functionalities as you get on Docker CLI, and the command paths are same. In addition to these utilities, NetCTL also gives you login and logout for container registries. It also gives you top events and system info commands with which you can figure out the details as you would do using the Docker CLI. Let's look at the demo. Here on this node, I've got container deconfigured and NetCTL installed. Let's begin with NetCTL version command. It prints the client version as well as the container runtime version here. You can also print the system information using NetCTL info or NetCTL system info command. These are the alias of the same command. It prints you the operating system details, kernel details, and what all components are configured in your server. What's the storage driver, what's the C group driver, and all that information. On the right hand side, I am going to run NetCTL events command that you can run to monitor the events that are happening in your node. With that in place, we will begin with exploring what all NetCTL has to provide. So if you print the help command, we can see here that the command help section looks like how it is for the Docker. And here you can see the management commands as well. So let's begin by creating a simple container. So here I'm creating the Nginx container. As you can notice, the syntax of the command is exactly same as the Docker CLI. It prints the container ID after successful creation. And as you can see here, the event is recorded at container create, and all the details of the container spec are present here. Let's look at the PS command, the same as the Docker PS command, with which you can see the running containers. You can also look at the logs of the containers. Say if you are debugging your container on a Kubernetes node and you want to inspect what are the logs of my container, you can use netctl logs command. As you can see, this prints the output in exactly same fashion as the Docker CLI. Let's press Control C to close that. NetCTL also has compose command. So I'm going to use this composed command to bring up a MongoDB, Nginx, and Flask app. This is to duplicate creating a few containers on the node and looking at various properties of it. So as it's creating containers, as you can see on the right hand side, a bunch of containers have been created. I can notice using PS commands, they just started. I can see logs of those commands to check if those are started correctly or not. You can see it started the worker process. I can also use the top command to make sure the process is running in my container or expectations. So if I have to debug something, I can use the top command using netctl as you have been doing with Docker to check the processes, their paths, the commands that's running inside it. All right. Let's look at other aspect of it. For example, we can look at the volume command group. We can see what all it has to provide. So netctl volume ls will give you what all volumes are present on your node. So you can inspect an individual volume here. And also look at, if you want to look inside the volume, what all data is present. So if your application is not behaving as expected, you can use all these commands to inspect volumes, go inside the data directory and inspect those files that are relevant to your application. That's for the volume. Let's look at what network subcommand group has. So with network subcommand, you can list, you can inspect NetCTL network inspect. So it will give you details about this particular apps network. So it prints you the CNI version that's being used, the CNI plugin here. That's 040. It gives you other details about, for example, what's a subway, what's a subnet, what's a gateway. There's also a port command on NetCTL which you can use to list the ports for a container. So for example, if you want to see, say, for example, this Nginx image, you can see that this Nginx container port mapping to the local host machine. You can also list namespace, NetCTL namespace, and printing ls will give you the currently there are 14 images, there are 19 images that are running in the default namespace with 9 volumes and 4 containers. You can also list all the exited containers here with ps-a. So at the moment we don't have any. We can kill a container as well. So I'm going to kill this container, and ps-a will show you that it has exited. You can look at the logs, how the container exited. So I think that's about it for the demo.
All right. I guess that's it about the talk, I guess. And we have Aditi and Naveed in the stream. And I think thanks for bringing up the topic again about Docker shame, deprecating, and all the way that people panic and everything is all fine. And thanks for presenting this talk, Naveed and Aditi. I think yeah, it's been really great and our pleasure. So yeah, so again, like your closing thoughts on the talk.
So like anybody who wants to understand more on this stuff, on the stack that goes on a Kubernetes node, they can reach out to us and ask question in the Slack, and can DM us also if they have any questions.
Yeah, so there are definitely few questions, but we can't take because of the time delay that we are running in. But then there are questions, as you could see, that there are questions about NerdCTL. Naveed would be happy to answer it definitely. And then there are questions about Podman and various other stuff, I guess other people were seeing. So yeah, thanks for the awesome talk. And again, we look forward to see you at the next Kubernetes Community Days, probably in person. Yeah, thank you.
Thank you, Arvind.
All right, I guess we are up for a little bit of kind of the next talk is going to come very soon, and yeah, that's it. I think. Great.
Elastic enables the world's leading organizations to transform data into actionable insights using the power of search. Given today's exponential data growth, it can be difficult to find signal through the noise. What we all need is a way to continuously gather data, to transform this data into insights, and to use these insights to take action. What we need is the power of search. Elastic builds and maintains the Elastic Stack, a data store, search engine, and analytics platform, all in one. And it's the foundation for our three primary solutions. Meet Elastic Enterprise Search, our fleet of search solutions. Enterprise Search enables you to quickly add a search box to a website or application, or to search across all of your productivity apps with a single interface. Meet Elastic Observability, our solution for unified visibility across logs, metrics, and APM data. Elastic Observability enables you to monitor and react to events happening anywhere, from applications, infrastructure, cloud services, microservices, and more. Finally, meet Elastic Security, our solution that unifies endpoint protection and SIEM. Elastic Security arms you to prevent, detect, and respond to threats across networks, infrastructure, applications, and every endpoint in your organization. And the best part? You can easily deploy any of these solutions as a managed service with Elastic Cloud. With one stack, powering three solutions that you can deploy anywhere. How will you use the power of search today?
Okay, so welcome back, and we'll be doing the next talk. So hope you're having fun. Make sure you keep asking questions on Bevy platform, and make sure you have all your questions there. You are active on Slack. Make sure you are filling the playing the quiz. So yeah, next talk up is provisioning infrastructure with crossplane. Very cool topic out there, and people are talking about it, and so we have this particular talk. So this talk will be given by Sahil Lakwani, and a software engineer, works on building software around cloud native technologies at InfraCloud. Besides that, he follows and tries to contribute to open source projects in the CNCF landscape. So here's the talk.
Hey everyone, my name is Sahil, and today I'll be speaking on Crossplane as a tool for provisioning infrastructure. A little bit about myself. I work as a software engineer at InfraCloud, and below is my Twitter handle. So today we will first go through the fundamentals of Crossplane, get an idea of what it is. Then we'll try to provision some infrastructure, and I'll be using AWS for that. After that, we will see how some features in Crossplane allow you to make abstractions over existing infrastructure resources, and then how it also helps you to build kind of a platform or control plane on top of your infrastructure. So Crossplane is a Kubernetes add-on that helps you manage your infrastructure. It does so by allowing you to represent your infrastructure resources as Kubernetes custom resources, or CRs. A quick example of that can be seen here. So this is a crossplane representation of a RDS instance in AWS. So it's a typical Kubernetes CR, and you have your API version, the kind, and a bunch of parameters. So once you install the specification in a Kubernetes cluster, Crossplane will take care of actually creating an RDS instance in AWS account, and then watching this RDS instance throughout its lifetime for any modifications. Besides, it also helps you build some abstractions and then package and distribute your infrastructure resources in form of OCI images. All right. Before we actually provision some resources, we need to understand that a provider is that actual custom controller that is running in a Kubernetes cluster and trying to sync the desired state and the actual state in the in your infrastructure or AWS account in this example. Provider config is nothing but a reference to a Kubernetes secret that is holding your credentials for the infrastructure provider. And then managed resources are the actual resources that you create in your Kubernetes cluster. So altogether, it may look something like this. You have a Kubernetes cluster, you install Crossplane in that, And when you install a provider like provider AWS, you get a bunch of CRDs, and the provider AWS is responsible for actually connecting to your AWS account and then managing all this actual uh, infrastructure resources which you have created through CRDs. So let's try to create the RDS instance that we saw already. So again, it's a typical CR. So I can just do kubectl apply and the name of the file. So once this is done, I should see an actual RDS instance getting created in my AWS account. All right. Yeah, so we have the output. Let's see if Crossplane tells us anything about the state of this RDS instance. Okay, so here's some metadata. So for example, these are the properties that we have provided with spec, and a property called state, which Crossplane fetched for us from AWS. So it says the RDS instance is being created. Let's go to the AWS console, and then we should have, yeah, we have a RDS instance that is being created. Let's take a look on yet another example. So I have this IAM user, and again, I can just do kubectl apply, name of the file. Okay. So again, I can take the state of that user. I can do kubectl get IAM user. Again, Crossplane has fetched some properties after the user was created in AWS. If I go to the IAM console in AWS, I should see a user created here. So after this is created, Crossplane periodically is watching these resources, the IAM user and the RDS instance, for any changes. And if it does detect any changes, it's the job of Crossplane to bring it back to the desired set that we had specified in our YAML file. So, for example, if I delete this user, Crossplane at its next reconciliation will detect that the user is deleted, but the user does exist as a CRD in Crossplane, right? So it will try to just create the user again, as we should see. Yeah, so the user is created again. So like any other Kubernetes resource, Crossplane uses the strong Kubernetes control loop to watch over the resources in any infrastructure, and then manages them throughout their life cycle. And by infrastructure, I actually mean anything that has an exposed API. You can just create a provider for that and use that with Crossplane. Let's go back to the RDS instance example that we saw earlier. So this was the YAML specification that we used to create just the DB instance. While actually creating DB instances, you might want to create some other resources like a subnet group or a security group to be attached with your RDS instance. To do that in Crossplane, you would typically write another bunch of YAML specifications and then install them to your Kubernetes cluster. While that works perfectly, you can get quite overwhelming because you will have a lot of resources to deal with and a lot of properties to deal. So Crossplane allows you to abstract all that away into a single resource of type called composite resource definition, or XRD. So for example, I've created an XRD called composite PostgreSQL instance, which exposes just one single property called as storage GB, and this will decide the storage capacity of my DB instance. All of the rest details are captured in another resource called composition, where I have for example, in this case, I have a DB subnet group, RDS instance, and the default properties of the resources. What I also have is the storage GB parameter, which is mapped to a field called allocated storage, which is a field that is actually accepted by the AWS APIs. And I can label that with a label something like this. So since this is for AWS, I can label it with provider AWS. So what this means is for the single XRD, you can write multiple compositions. Let's say, for example, other than this AWS composition, I can write another composition for GCP. And then the users, when creating an instance of this XRD, are free to choose where they want to create the DB instance and accordingly choose the composition that they want. Another type that we can see here is a composite resource claim. That is nothing but a namespace proxy of this XRD, which is automatically created by Crossplane. So in the end, when you install the XRD and the composition, then you can just create a DB instance using any composition with a simple YAML specification such as this. So as you see, I'm just providing the storage DB parameter, and I'm choosing my composition using a field called composition selector and providing the label. And if I want to create a DB instance in GCP, I can switch to GCP, provided that I have a composition for GCP and it defines the respective cloud resources that are associated to a DB instance in GCP. So once you do that, you can also package this composition and composite resource definitions into an OCI image by writing a configuration file. And then you can just push it to any OCI compatible registry and then allow others to use that. So using features like composition and composite resource definition, you can build a sort of a platform that sits between your infrastructure users and the infrastructure itself. This allows you to build a control plane so that your users do not directly use the infrastructure, but instead use your control plane to actually manage some infrastructure. Since all of this runs on Kubernetes, you can use some sort of policy manager for Kubernetes to establish an RBAC framework over all these resources. So for example, here, using the same database example, I can create an XRD which will point to a VPC which I had created in prior. And then I can allow users to create their own database instances, which will be scoped to their own namespaces. And they are free to use compositions like dev or prod based on their requirements. So in this way, a platform operator can just impose some restrictions like the restrictions on the field, decide the level of flexibility to be given to the users for using the actual infrastructure. There are a bunch of other features that you might be interested once you start working with Crossplane. I suggest you visit the Crossplane docs or join the community on Crossplane Slack to know more. That should be all from me for today. Thank you.
Yeah, thank you, Sahil, for the amazing Crossplane talk. So I think people have enjoyed that. So Sahil will be there on Slack. So if you have any questions, please shoot out them in the Slack channel, in the thread where Sahil is there to answer any questions related to Crossplane. Very interesting tool, and I think people have now started using it in all over the place. So yeah, great talk, Sahil. Anything you want to say to the community?
Yeah, it's a fast growing community within the Crossplane. There are, as I said at the end of the talk, there are a bunch of other features you might want to check. So yeah, hope you find it easy to manage your infrastructure.
Awesome. Glad to have you, and looking forward to have the next event in person and see your talk again.
Sure. Thanks for all your efforts to this event, Sam.
Awesome. So we'll be having our next talk shortly. Okay, so we are reaching the end of the talks for track one, but still the last but not the least, it's the awesome talk on zero to secure, how Kyverno can help secure your cluster. Basically, Kyverno is a policy Kubernetes policy engine tool, and it helps you to write the policies in Kubernetes native way. I have done a lot of streams on Kyverno, and I think I really like the product, to be honest. And today we are joined by Dolish Sharma, who is the DevOps engineer at Nirmata and manages production Kubernetes cluster for Nirmata, and also works with customers for issues with the Kubernetes deployments. She's an AWS certified architect and preparing to be certified Kubernetes administrator. Hope today's AMA session was helpful. And along with Dolis, we have Pooja Singh. Pooja Singh is software engineer with Nirmata, working full-time on Kyverno. Pooja has spent more than 5 years building product and services, being from analyst, developer, tester, Ruby on Rails, automation, UI, path, and a lot more. And she is a certified Kubernetes administrator. So glad to have that, and let's begin the talk.
Okay, so here's the situation. A new team member set up a Jenkins cluster and the CPU keeps spiking to 100%. When I investigated, I found that it did not add pod security policies as they heard PSPs were depreciated. The lack of pod security on the cluster allowed intruders to run privileged pods and launch crypto mining workloads that causes the CPU to spike and results in large cloud provider bill. While it's true that PSPs are marked for depreciation in version 1.21, you can still use them until an entry replacement is ready. However, implementing PSPs has many challenges, which is why they are depreciated to begin with. So, what's one to do? I've heard about this new CNCF project called Kyverno, which also implements pod security, and I know one of the maintainers. So let's learn about it and see what it can do. Hey Pooja, thank you for hopping on the call real quick. I am actually in the middle of a situation. So there is this Jenkins cluster which is running a pod that has security context set privilege is equal to true. Now I want to make sure that creation of such pods are blocked.
Okay, so you're looking for pod security policy that can block this pod.
Yes, this is exactly what I'm looking for.
Have you tried PSPs?
I was thinking of implementing PSPs, but again, it has its own disadvantage.
Makes sense. So did you try any other policy management tools?
I checked Kyverno and OPA, and I recall that you were involved in some Kyverno's project. So can you help me to understand which will be the best case to use here?
Sure. So let me tell you about both Kyverno and OPA. Okay. Kyverno is a policy engine designed specifically for Kubernetes, and it has a full implementation of pod security standards and other policies to help secure configuration. While OPA, it is general purpose policy engine, and it provides high level declarative language that lets you write specific policy as code. Its policy are written in Rego.
Oh, Rego. So is there any other language to learn?
Yes. But don't worry, Kyverno comes handy here. You can write policies in YAML, so no need to learn new language.
Awesome.
So can you show me the pod configuration so that we can check it quickly and we can decide what kind of policy we need here?
Sure. Let me share you my screen, and yeah, this was the pod YAML file I was actually looking at, and if you can see, the security context has set privilege is equal to true here.
Yes, and I can see that it has host access, which is not secure. So I think yes, this Kyverno fits very well here. It is specially designed for handling these kind of scenarios.
Oh, it's really, I'm really glad to understand that Kyverno is the best use case here. Can you tell me more about Kyverno?
Sure. Kyverno actually runs as a dynamic admission controller in Kubernetes cluster. This means all the Kubernetes API requests can be validated or mutated by Kyverno policies. When we install Kyverno, it will register itself as a mutating and validating webhook. Based on the policies we define in the cluster, Kyverno can validate, mutate, or generate new configurations. I have shared you a link. So let's try installing Kyverno in your cluster.
Okay, so you're telling that the single link will help me to install Kyverno in my cluster?
Exactly.
Okay, so let me install this pretty quickly. And here it goes. I think this is getting installed. So let's wait for a while, and yeah, it's created. Can you take a look at your side and check whether the configuration looks good?
Yeah, sure. Okay, so here we can see Kyverno pod is running. This means Kyverno is installed in your cluster. So now coming back to your use case, first let me explain the policy structure so that you will understand it better when we apply it to your cluster. So here, this is how policy structures looks like. Under policies, we have a collection of rules. Under rules, we can mention match and exclude clause. And these are the parameters which you can mention under this clause. So here match means the resources you can mention under this is on which you want to apply the policy. And similarly, exclude is the resources which you want to exclude. And under rules, you can mention 3 types, that is mutate, validate, and generate. So now let's cover your use case policy, which I have it here.
Oh, perfect.
So as your use case was regarding the privileged containers, this is a perfect policy for you. And this is a validate policy. So what it does is, it will be applied to all the pods which will be created, and it will match with this specific pattern. So here we go for the definition that validate does the validation of the resource with the patterns which we mentioned here. So what this policy will do is, it will go and check in the pod for this specific words, that specific keys, that is spec, init containers, security context, and privileged. So at the end, you will go for the policy will check for the privileged keyword, and it will check that its value is false. If the value is false, it will allow the pod to get created. If it is true, then it will give this error message. So it will log the policy. So considering your use case, I have just changed a policy a bit. I have added an extra parameter that is namespace dev all. So what this policy will do is, it will be applied to all the pods which will be created in this specific namespace. So now let's deploy it and see how does it work. Okay, so see. So
I think Sophia applying the policy. Yeah.
Now let me check.
Let's create it.
So this is applied.
Yeah.
Now I have a sample pod YAML, which is similar to what you showed me. Now let's try to create this. So yeah, so the pod is blocked. So now your cluster is safe from all this kind of pods and it is secure now.
Yeah, so this is really awesome, Pooja. While you were doing this, I was thinking of some more use cases. So can you tell me some other kind of policies in Kyverno?
Sure. Okay, so here are the three type of policies what we have. So coming to the validate policy, I already explained it with your use case. So let me explain you the other two types, which is generate and mutate. So coming to generate, let me take a simple example. Okay, so we have an example that is add network policies. So what generate does is it will help you to create an additional resource on creation of a new resource. So here you can see what will happen is this policy will be triggered when you create a new namespace, and it will generate a network policy under the created namespace with this inline data. So this is a simple generate policy example. You can also go and check for other generate policy through this filter. Now let me explain the mutate policy. So mutate policy are basically used for modifying the matched resources. So if you say this policy, this will add label to these matched resources.
Okay, so this is awesome, Pooja. Let me go back and secure my cluster. Also, wait a second. How do I learn more about Kyverno?
I have shared you the documentation for Kyverno. So you will find a GitHub link on the same. And there are also free workshops and training from the company like Nirmata, who created Kyverno. Ping me in case you feel need anything else.
Sure. Thank you. Thanks a lot. It was really helpful. Thank you a lot. Hi, my name is Dollars. I'm working as a DevOps engineer in Nirmata.
Hi, this is Pooja. I'm working as software engineer in Nirmata.
So today we saw how Kyverno can help secure your cluster in under 5 minutes. Details are available at kyverno.io.
Please check this out and hope it helps.
Thank you.
Thank you.
Awesome. So that was a nice session on Kyverno. So it's very exciting project, Kubernetes native way of writing policies. I have used that myself. So I really like that, the Kubernetes approach, because no need to learn any new language and you can still write the native policies. So that was a well-structured and kind of a nice storyline. I really like the kind of, you have a storyline that you tried with explaining the product, which was very cool. So really nice talk, Doris and Pooja. Really glad to have you for the session on Kyverno. Anything you would like to add and say to the community?
I would say that I was actually thinking of all the fun we had while recording this session. So I was just, I went back. Okay, so you can get all the details on kyverno.io. You can reach on to the team on Slack. All the details are available at kyverno.io. And I hope you like the session.
Absolutely. And also Dolis and Pooja, they both will be there on the Slack channel, KCD Bengaluru. So make sure if you have any questions regarding in general Kubernetes policies, Kyverno versus any of the tools. So I think they'll be able to help you out over there. So thank you both. And with that, we'll be back in a few seconds.
Hi, welcome to Learn Kubernetes with Google. My name is Aldo, and I'm a software developer in GKE.
My name is Isabel, and I'm a cloud engineer in Google Cloud Professional Services.
I'm going to teach you about the Kubernetes Gateway API.
Switching to Containerd, as the container runtime eliminates this middleman.
Just look at them. So as above.
Okay, so the track one talks are actually done, and we had really great fun with the track one talks, but the show is not over yet. We still have track two talks, a couple of them still going on, and after that we'll be having that ending session. So I would request all of the participants who are there in track one to move to track two, and also make sure you fill out the Kubernetes quiz, because that is a way where you can win the swags, and also fill out the scholarship form that can lead you to win a complete the Cloud Boot Camp by Linux Foundation. So yeah, I'm really happy with this conference that is going. So we have successfully completed track one. So happy for that, and thank you all for joining in. Please move to track two so that you can enjoy the next set of talks over there, and then we'll do the ending ceremony. So anything else you want to add, Prakash?
No, so I really enjoyed the track one sessions, and let's see. There are some more exciting sessions. Especially, I'm excited for the talk by Kunal, so which will be on track one. So I would request every one of you to move to track one, and we'll see you there.
Yeah, so please move to track two, and thank you all, and I'll end the broadcast for track one.